between that.
Yeah.
Oh, Farmer's here. I can go live now.
Just woke up from a snooze.
We're keeping you up, Farmers.
I don't know what I just sat down with I got halfway through a cup of tea and don't know what I was reading, and the next thing I'm like, where am I? What am I doing? I think I had about half an hour.
Yes.
Oh dear.
I had that lunchtime. I put on some stuff to have for lunch and then sat down for a little bit and then realised I'd fallen asleep. Luckily it wasn't. It was on a timer and didn't burn the house down.
It's when you suddenly come to and think, what the hell was that bloody noise? And then you realise that was you snoring.
Yes. I've been woken up by that.
Oh, shit, yeah.
G'day, Matt. How you going? Matt's not talking to us.
I guess Matt's muted at his end rather than in the Zoom call.
Wrong microphone setting. Bloody, it's when you have these stupid wireless bloody headsets for the microphone, and wherever you go, it keeps changing it to what you don't want.
It's
Pain in the arse.
You seem a bit quiet this morning, Matt.
Oh, am I?
Oh, sorry, low on your audio, at least.
Sometimes he's worse, so he said...
Is that any better?
No, not really.
Not really.
Oh,
no.
Okay. I can hear you okay, though. I can hear you okay, though.
Carry on and I'll... that's all right, then. But carry on, then I'll fiddle around.
Yeah, but you're just a little bit lower than normal. But
All right. Oh, I might have to go and have another half hour.
If you start snoring on stream, we'll have to mute you, you know.
I mean, I've been out, you know. I ain't got a haircut this morning, but I just all of a sudden it was just gone.
Age, that's what it is.
I think so.
Age.
Is that? Yeah, I just noticed. Is that not a bit shorter than usual?
No,
It's quite short, isn't it?
Every 6 weeks. That's a number 4. That's a grade 4 all over.
It looks a bit shorter than number 4.
Yeah, it looks really short today.
Looks like
no, it's the same. No.
Looks like a 2.
I've had it that short once, and all I needed was the card with my name and the number on it. Going to the camera, you know. I think that was that was many years ago. I managed to get my hair down to my shoulders because I wanted long hair. I was determined to have long hair. No.
Yeah, we can hear you, Matt.
Because it also looks like. Sorry, it also looks like it's shorter on the sides than it is on the top. Like somebody's gone down just at sort of that level and done the bottom half a little bit shorter.
No, same setting all over. The same haircut I get on average 6 weeks because it gets too long and I tend to sleep on that side, so you end up with a ridge in your hair because you've slept on it all night like that. Because my hair grows really thick. That's why when it grew it down to my shoulders, it had to go because it was just this huge, massive hair. You know, it's bloody awful. So Mum said, "Get yourself a haircut." So I come back and she went, "What do you call that?" I said, "That was a grade 2." Like something out of Good Morning Vietnam.
Hey, can I hear me okay out in the... Hear us, you guys out okay? Must be. It's okay, just wasn't sure. Tune test had he can barely hear you, but... Okay. Well, let us know. According to my thing, we're going out, but yeah. Here's Blue. Good. And Matt, yes, we could hear you testing. Just so you know. Well, so you've had 2 weeks. What exciting things have happened in the flat earth in the last 2 weeks?
Well, Wixie made a complete arse of himself.
I only watched a bit of it.
It says something when even InfoWars thinks you're an idiot.
It's round. That's it.
Yeah.
Yeah, when even that Chundering Thunder Monkey says, "Yeah, no, it's round." Sorry, being Dad used to look at things through telescopes. The Earth's not flat.
I heard that Takori numbnut on MC Toons say that asteroids couldn't exist in outer space because supposedly it's a vacuum out there and there's no medium for the asteroids to fly through.
It's even worse. There's no medium for a medium to exist in.
Yeah, I know.
Oh dear. It's like how can light be coming from the sun because space is black? You know, the sunlight's not lighting anything up.
Yes.
Yeah, it's not lighting anything up because there's nothing there to be lit up.
Yeah, there's nothing for the light to travel through. Go on, Matt.
Something slightly different, but along the same lines of things not working off of something. There's one guy quite popular on Twitter, he's a flat earther as well. He said that a heartbeat can't work in space because it hasn't got a magnetic field to work off.
What?
I saw that. It's like...
Oh yeah, because you replied to it, didn't you? I think because I reposted it. What? It needs a magnetic field to work off. Come again? What? Oh dear.
Oh, yeah. Problem is they're running out of things to be wrong about, aren't they?
I don't know. They seem to be very good at finding stuff.
They tried all the slightly. I mean, this is why I was having a conversation with Red Reddick on Twitter Space, and basically, I mean, he's saying that I totally agree with him. They've run out of completely all the intelligent things to say about. Oh, well, you say intelligent. Run out of anything reasonable to argue about. It's all been completely debunked and shown up and all the rest of it. So now they're just coming out with even more incredibly dumb stuff. So rather than get like a little bit more reasonable, it's actually getting worse. They're just coming out the most ridiculous stuff, like things like, was it really the moon that was showing doing the eclipse, or is the sun really hot? You know,
yes.
Early, 2017, 2016, you probably wouldn't have heard that. You know, but now, that's what kind of stuff that you hear all the time.
Yes.
Yeah, they seem to be flying backwards in two opposite directions somehow.
Yeah,
that's right. Good analogy.
They either go completely wacko off the deep end in word derp, or they go back to the very basics like that. Tricori, whatever that guy's name was that Paul was talking about.
Yeah.
To the extent that they can't figure out that weight is a force.
Yeah.
Yes.
Or a conversation I had in Discord with Brian Leakey the other day, and Leakey cannot wrap his head around the idea that velocity and acceleration are not the same.
Yes.
That kind of puts you at a disadvantage of understanding anything about physics, doesn't it?
Yes.
Yeah, it does.
I mean, it's like physics 101, but 101 of 101. If that makes sense.
Yes.
It's like page 1 of 101.
Physics .101.
It's like it's like the second day of physics. That's only because the first day the teacher was away.
Yeah.
Page.
Yes, but remember, it's kindergarten science class, not high school science class.
Yeah.
They are small and they are far away. There we go. We'll start with that.
I found this guy who's going to tell us about tides. Do you want to hear him?
Oh
yeah, go on then.
No, not him, please, not him.
Oh, yeah.
Oh, no.
Oh, yeah. Oh, yes.
I had a student once tell me that nothing could travel faster than the speed of light, because if it could, then it could turn around and watch itself arrive.
Yes.
It would see itself coming.
Yeah, exactly.
Yeah, it would.
I
Where do
believe
they
it.
get this shit?
Yes.
I'm just
Okay.
going back to sleep, so.
I'm Fake
Hey,
Kid from
here
Brazil,
you go.
and I'm here in Turkey today to explain to you about the tides. Tides are very different. Everywhere you go in the world, they're different from place to place. They can be a lot bigger in some places and a lot smaller in others. Here in Turkey, for example, there are virtually no tides on all seas around Turkey. Turkey has here to this, where I am in Didim in Turkey. Here, this is the Mediterranean or the Aegean Sea, the Aegean and the Mediterranean. So here the tides are negligible. I'm going to turn the camera so you can see how negligible the tides are at low tide. It's low tide now. Check it out. So this is low tide. Here it's about 12-13 centimeters. Very, very small tides. In other places you get 12 to 13 meters, like in Liverpool in the United Kingdom, and also Bristol in the United Kingdom. You get there 11 meters, 12 meters of tides. Here you get 12 centimeters of tides.
Yeah, well, that starts off today. Where are we going with this?
Hey, here we get about 12 centimetres of tide on the river, 25 miles from the sea.
Yes. Yeah.
So when we talk about tides, we have to consider these things. So believing in gravitation of the moon or diamagnetism of the sun, things like that, things related to the stars and the sun.
Yeah, demagnetism of the sun causes tides, according to us.
Demagnetism of the sun.
Yes, that's what he said.
The moon have nothing to do with the tides. They don't explain. What happened in the tides. If they did, then there would be some correspondence between.
Correspondence. Yes, I think that.
They don't explain what.
And they don't coincide either, apparently. So,
In the times where the sun goes and all the incidents of the sun, the tides would respond to that. There would be a bigger area where the tides would happen at the same time. We don't see that in places like the United Kingdom. We have tides completely opposite in times, in very small distances, like Bristol and Bournemouth, and also sizes between Bristol and Bournemouth. Like the distance is about 100 miles. 100 miles in distance, but the size of the tides is ridiculously different. In Bristol you get up to 12 meters, 12 meters of tides. In Bournemouth you get about 3 meters.
Really?
yes, it's got to do with the topography of the shore bottom, nothing to do with that.
Yeah.
Yeah, well, when you pile a bunch of water up in a bottleneck, yes, that will happen.
Yeah.
And around the Solent area, they sometimes get 4 high tides a day.
Yeah.
Because one lot of the water comes down the North Sea, up the English Channel, and meets around about where the Isle of Wight is.
Oh, yeah.
And they're at different times.
Yes.
Tides. So the sizes are very
It's almost
different.
like there's,
and also,
it's almost like there's 2 really big gravitational bodies out there doing shit, right? I don't know. Let me think.
Big gravitational bodies, so that would be the fat slags.
Okay.
If Witt's ego had gravity, this place would be a fucking black hole.
Okay, so can any of us guess what he thinks the solution is? What actually tides are caused by?
I've watched one of these videos and I can't remember what it was.
so
Isn't it
you
the
have
Earth
there.
What do you think, Thurman? Take a guess.
Yeah, I agree. Alan, I think I'm going to go with what Alan said because it's completely bonkers, and he sounds like he's completely bonkers. So the earth breathing. Yeah, I agree with Alan.
The earth breathing.
I know that come up lately
Yeah.
from somebody.
You have the times of the tide. So when one tide is high, the other one should be high as well. They should be high and low at the same time. They should be up and down at the same time. If the stars above, like the sun and the moon, made the tides, it's not what happens. You get high in one and low in the other, or one growing and the other lowering. So the tides
like
don't
water takes
correspond
time to
in
flow
time.
somewhere.
It does.
Yeah.
It's almost like it happens in different parts of the world.
Yeah, I was going to say different part of the world. Really does it? Wow, that's amazing.
It's almost like the moon can't be over the same over everywhere on the earth at once.
That's right.
You can get completely opposite times in a very short distance, like London and Medway, for example. Or also any other place in the world. Like, for example, in the Bay of Fundy, you can get 13 meters in Port Elmhurst. In Port Elmhurst, you can get 13 meters. And in Port Elgin, that is about 20 kilometers away, 20 miles away, really, really close by, you get just 1 meter. So it has nothing to do with the moon or the sun. It has nothing to do with that. So what causes the tides is a system of springs underneath the water. So underneath the water, we have lots of springs, plenty of freshwater springs, just under all the ocean, just as many springs as we have above the sea level on the continents. There are also plenty of freshwater springs in the ocean.
Thomas, don't worry, it'll be over soon. I promise.
Oh,
It'll be over soon.
real.
Thomas, I promise.
Make it stop.
Oh yeah, but
Okay, so we got all this water going in. Where's the gazouta? Yeah, I mean, it's
And
got
they
to be
have a
going
lot more
somewhere.
pressure.
It's got to be a plug hole
You
somewhere.
got, yeah, there's a gazina. Where's the gazouta?
and they're very regular, these springs too, by the way.
A lot more pressure. And also they can be intermittent
Who turns
or
them
permanent.
off and on?
So those permanent perennial springs, the ones that make rivers, for example, they inject water all the time. But there are plenty of intermittent springs which only inject water for some period of time and then they stop for another period of time and then they stop. And that explains the tides, because some tides are also longer than others. There are places that take 5 hours to grow until the high tide. Some places take 6 hours to go until high tide. And some places go for 6 hours, then they get lower, but not so much lower. They get, for example, they go up to 4 meters in high tide, but then in low tide it's 3.5. 3.5 meters is also pretty high tide, but they consider as low tide. That's because the springs that are underneath the ocean, they work in an intermittent period. So when one starts, the other one may start a bit later. So they can work for about 9 hours. So you get 6 hours of a very high tide and another 3 hours of not so much high tide. So that explains the tides, for example, near Vancouver in Canada. They can last up to 9 hours, still very high. So about,
But where's the
about
water
6
going?
hours
That's
and
the
4
question.
meters, and then about another 3 hours,
Yeah,
3.5, which they consider low, but it's not actually low. And then it goes to another high or to a very low of a 1 meter much later on. So this is what explains. It's the springs that we have
goes
under the
to a
ocean.
special place.
So there are plenty of them, injecting fresh water all the time, intermittent periods, but they keep injecting, renewing the oxygen in the water. Otherwise, the water would become too salty because the salt is already in the ocean, in the salt mines. There are plenty of salt mines, and that's why the ocean gets salty. Here where I am, for example, the salt.
You like that one?
So if we didn't mine all that salt, then the water wouldn't be salty.
And so it wasn't salty a long time ago when we didn't have these salt mines. So
Yeah.
Well, I knew humanity was stupid, but going putting all that salt in the ocean deliberately, I mean, good grief.
Salinity is higher than other places. Here in the eastern part of the Mediterranean Sea. The salinity here is higher. Here is 38 grams per liter, 3.8%. Whereas to the western part of the Mediterranean Sea,
3.4%.
the salinity there is 34 grams per liter. So that's about 3.4%. So 3.4% there, 3.8% here. There is more salt here than there. And the reason is the tides. The tides explain the salinity. Because here there are very small tides. As you can see, the tides here. I'll show you again. This is low tide. This is low tide. Look. Low tide. You get a very, very, very small variation. So this is about 12 centimeters. That's the tides that we get here in this area of Turkey. So because of the low tides here, the salinity becomes higher. That's why there is more salt in this water, because there is less fresh water being injected here. That's why. This is also something that most people don't know. Salinity has nothing to do with tides. It's the opposite. The tides have to do on the salinity. They control the salt. And that's why in places with very small tides or virtually no tides...
Where does all this fresh water come from?
Yeah. And where's it going?
The bosoms.
Does it suck it all back in again? Or I mean,
Yeah, we hasn't got an explanation of that yet. So,
like the eastern part of the Mediterranean, the salinity tends to get higher. The same happens, for example, in the Red Sea. The Red Sea has 42 grams, 41, 42. It has a gradual salinity, just like the Mediterranean has a gradual salinity. So the closer to the salt mines, the saltier. And the amount of fresh water injected there is also very small. So the tides in the Red Sea are also pretty small, just not as small as they are here. Here it's even smaller. And the whole of Turkey has very small tides. For example, the Sea of Marmara. The Sea of Marmara to the south of Istanbul is also like this. Tides there are about 4, 5, 10 centimeters. Really, really small. They can be considered as amphidromic points. Many scientists call these places amphidromic points. They don't even know what amphidromic points are.
okay, they gave them a name but don't know what they are. Okay.
And they just say it's amphidromic points because from these places the tides begin to be noticed. That's how they say. Well, amphidromic points are, in my conception, what finishes with the tides, what kills the tides. So the tide is the injection of water. The tides is the injection of water, and the amphidromic points, they suck this water out from the ocean. So the water is injected in many parts. The tides are made, and then the tides spread around the ocean, spread over there, spread, and the level remains the same. So the level remains the same because there are amphidromic points which suck the water from the ocean constantly, permanently. There are many points like that. I don't know all of them, but I know many of them. So there are two in Norway, for example. There are 2 points in Norway. Like they make huge whirlpools on the surface because they keep sucking a huge amount of water permanently from that area of the Atlantic. Also in Scotland, in the Gulf of Corrigan, there's another one. And here in the Mediterranean Sea, there is one in the center of the Mediterranean Sea in Messina, Italy. So there in Messina, there is one amphidromic point. That's the amphidromic point of the Mediterranean Sea. So all the tides made in that area, because in Venice there are tides, you get up to a meter in Venice. There are tides in the south of Spain, France, northern Morocco, Tunisia. You get small tides there, about 60 centimeters, about, I don't know, maybe 80 centimeters, 40 centimeters. So it's about 4 to 6 times higher than this side. So here in this side we get 10 centimeters maximum, 12 centimeters, 4, 5 centimeters, really, really small tides, because they get to here when they arrive here, the tides are already a lot smaller because they've been sucked there, and also they've diffracted in many of the islands, so they get here a lot smaller. But to that side there are some tides. So these amphidromic points is what sucks, removes the water from the ocean and probably brings it back to.
So he thinks a whirlpool is an amphidromic point. It's not what it means.
No, not what an amphibian point is at all. But that now he's just discovered a way of, if he's got these springs that are injecting fresh water into the seas, creating tides, he's now got whirlpools that are sucking water back into inside the earth, because presumably that's where the water's coming from.
Must be, yeah,
So
right.
that's where the water's going to. I mean, he's absolutely fucking batshit crazy.
But somewhere down there's a great big humongous pump that circulates all the water, right?
Yeah.
Yes, must be.
Well, obviously,
How do these big pumps as well know about the phases of the moon and how?
Yeah.
Well,
it's a bit.
well,
strange.
the other bit-
No.
well, the other big question is it's sucking down this salt water and pumping out this fresh water. So, where's all the salt going?
Yeah.
Oh, didn't he say that the sun is? Oh no, that was demagnetizing, wasn't it? Not desalinating.
Yeah.
And it can't be the salt mines that are making it salty, because don't we take the salt away from the salt mines?
That's right. We just don't leave them there and get washed away from by the salinity. Yeah,
Or are they just mining the salt and then chucking it into the sea?
must be. Yeah.
Yeah.
Origin. The place of
It's not
origin
salty
is the
enough to throw some in.
Yes. And some of these places that have salt mines, like Sweden, is well known for its salt mines. So, obviously.
primordial ocean. So we have a primordial ocean, and the water from the primordial ocean is pure, is drinkable, is pure water, and that pure water is what is injected from underneath the ocean and also on above the sea level in the continents. We also have plenty of freshwater springs. About 99.99% of the springs is fresh water. Just not dot 99. Almost nothing, almost very few
Your English
of
isn't
the,
your
of the
problem,
springs
mate.
that we have above the sea level contain salt or a gas or some sort of sulfite or some other sort of like a iron. They can contain iron as well, but
Cations.
the
What
majority,
is it? Cations.
99.999% of them is fresh water. So that's because the water outside the firmament, the water outside where God is and the angels, that water is pure, and that water penetrates from underneath, and that's what keeps us alive. That's what keeps us alive. That's what keeps the levels of oxygen in the ocean.
There you go.
Except that in this demonstration, shouldn't we be drowning by now?
Good.
Yeah.
And
So he's the
keeps
one who
alive,
got the question and things like that.
in
He
the
would just
ocean.
resort.
Without that water, we would die. The ocean would be.
Yeah, God. Yes.
I mean, why would I believe anyone who doesn't even know enough maths to be able to say 99.9%? Yeah.
Even though that's not a correct statistic, it's what he made up.
Become salty, just like the Dead Sea. It would kill everything. So that's the water from the firmament, from outside the firmament. The waters above, that's what keeps us alive. So and that's what explains the tides as well. So it's this is the explanation of tides, guys. Right? The water from outside, the water from the primordial waters, they penetrate from underneath in certain points. In points like this, in places like this, like the whole of the western part of the Mediterranean Sea, including the Aegean Sea, the Marmara, the Sea of Marmara also has no tides. The Black Sea has no tides. Also the Caspian, I'm sorry, not
I think
the
it does
Caspian,
have
the Baltic,
tides, actually.
The Baltic in the northern part of Europe. The Baltic Sea has no tides. Tides in Helsinki, tides in Stockholm, they are virtually zero. They're even smaller than this. Even smaller than this. Here we get about 13 centimeters. There they get like 4 or 5 centimeters, nearly nothing. In the south of Norway, in Egersund, they have nothing. They have like 5 centimeters, 10 centimeters. In the Sea of Japan, in the areas of Metsui, in the areas of Totori,
all these
in the
amounts that he
areas of
keeps
Shimane,
saying enough.
in those places, they have virtually no tides. It's like this also.
Yeah.
Like 10
Because you've got a great big freaking ocean called the Pacific. You moron.
Well, it's all these places that have low tides. What about all the places that have high tides? Like, oh, no, sorry, larger tides in numbers. What's your explanation there?
Well, like the estuary, the Bristol Channel. You know, I mean, it's all concentrated. That's it's not difficult. You know,
I'd love to see him use his model to predict the tides somewhere, right?
Yeah, that's right. Yeah, it should be able to.
Yeah.
Yeah, we can. So surely by now you could measure it all and work it out. And you'd be able to find a correlation between the location of springs and where the tides are, right?
Yeah, you should be able to measure the difference in the saltiness of the water.
Yeah.
Meters, 15 centimeters, 5 centimeters, like nothing. So in places like this, there are no tides. And the reason is because there are no springs. There are no springs underneath. That's why. And that's the explanation of tides. It's the springs underneath in high pressure. When these springs, they burst, depending how close they are to the surface also, and depending on their magnitudes, they can change, they can alter the surface of water. You can have that surface of water that is very similar to when you spring water from underneath a plastic pool, a plastic swimming pool that you have in the garden. If you put the water, injecting water from underneath in the pool, you get the same effect that you get in some parts of the ocean. You get that water opening in a circle in the surface, changing the texture of the surface of the water. The same thing you can get in the ocean as well. That texture becomes smoother, glassy. The texture of the surface changes, opens in a wide circle, and spreads over the ocean. So half of that circle comes to the coast, and the other half goes to the other side of the ocean. Sometimes, if you have a channel, it goes to the other side of the channel. It happens in the channel, in the English Channel, for example. This is what explains the tides in the English Channel, where you have in the side of France, in Saint-Malo, you have, for example, about 11 meters of tides in one side of the channel, but in Bournemouth, to the other side of the channel, in Bournemouth,
but you don't have a big spring in the middle.
3 meters of tides. So this is what explains the tides. So the tides open, half come to one coast, and the other half goes to the other coast.
Yeah.
And some.
Yeah.
But
yes.
The thing with the tides at Bournemouth is getting its tides from the tidal surge that runs down through the North Sea and out the English Channel.
Yeah.
While St Malo is getting its tide from the Atlantic that's coming in that also fills up the Bristol Channel and up the Irish Sea, where they have big, huge tides.
Yeah.
So he's literally picked two places that kind of look opposite each other on the map, but are getting the water from their tides from completely different sources.
Yes. Well, he's missing a whole lot of stuff. So, I think he goes on for a bit. Let's see.
Spreads to the sides
because
as well.
all these tides and these bulges are like, I mean, these springs must be massive, or is he saying that there's thousands of thousands in one spot that causes these big tides in certain areas?
I think
he thinks there's black smokers everywhere.
Yes.
Like, must be thousands of them, like these little areas.
Yeah, not just in the deep ocean near the mid-ocean ridges.
Yeah.
Yeah. I suspect he, like all flat earthers, has no concept of the scale of what he's talking about, how much water we're talking about.
Yeah. Yeah.
So that's how the tides are made, from underneath, and they open and they change the texture of the surface in some places depending on the depth and also on the magnitude of these springs. So if they have a very high, very intense magnitude, they can change, and also if they are very close to the surface.
So why is the salinity in the English Channel not that much different? So you have this massive tide, spring in the middle of it.
Obviously, if it's very, very deep, too deep, they will probably not change the pressure won't be enough to change the surface and create that effect of a different texture. But depending on the place, yes. So, for example, in these images that you're seeing there.
Yeah, I think it's just on and on about the same stuff after that. There you go. Any fun? Yes.
Wow.
Yeah. Wow.
So they're out there. They're still out there. I don't think he holds. Go on.
Completely incapable of putting his theories to even a modicum of sensibleness. You know, like can't even say, well, what could be wrong with this? No, completely incapable of doing that.
Yeah, he's not willing to check his own theories, is he?
No.
I mean, that's what scientists do. They're constantly trying to debunk themselves, really, in an essence. And that's why science changes.
Like if there were these massive springs erupting fresh water in the bottom of the ocean all the time, why the hell can't we find them?
Yeah.
I somehow think we don't fully understand the concept of volume. Perhaps he should look into that.
A bit more. And why is it when all these? If you look at every single conspiracy theory, and I think you've got one thing that's in common, it's always really complicated, isn't it? Any conspiracy, it doesn't matter what it is. If you look into it, it's always complicated. It's quite often as the truth is just the simplest thing, and it's quite often the thing. It's just a very simple explanation for something, and laws of nature and stuff like that. If you look at them, really, they are quite simple. A lot of them, except for I don't know, maybe quantum physics, maybe. But
I was going to say,
yeah. You know what I'm saying.
Yeah,
you know what I mean. It's like they're always really complicated. Instead of looking at something, well, why don't you just consider this? It's a very simple explanation. Why don't you consider this? Oh no. My very complicated theory is much more viable. Yeah, okay. Carry on.
Well, what about general relativity?
Yeah.
It's like that sketch in Monty Python's Life of Brian. What have the Romans ever done for us?
Apart from all this either.
It's all very simple, except for quantum mechanics and general relativity.
Oh, we ought to do a sketch on that. Yeah, what has science ever done for us?
Oh, by the way, this guy did put out another video. Or actually, he's put out several. Do you want to see a picture of what he thinks is one of the things sucking the water back in? Hang on a sec. I won't play the whole of his video.
Go on, let's look at that.
Because it's pretty much the same.
In the United States, and it's called the Lost Lake. So the Lost Lake is a very interesting one because we can see the hole when it's draining. It happens every spring.
Oh no!
The Lost Lake, you can see it in the spring. Many people have seen it. It's spectacular to see the water being drained down the hole inside that lake. And it happens in any other turlock. They all have a spring and a hole in the north.
So sometimes the hole was closed then, is it? And somebody pulls the plug and puts the plug back in again and...
There you go. That's the sort of thing he thinks is sucking all the water back up.
Yeah.
Well, there was that hole they drilled in that lake in, was it Alabama or Louisiana?
Yeah, well, that was into some mines underneath, though. Go on.
Yeah, they drained a lake into an abandoned mine.
Yeah.
Well, I don't think the mine was abandoned. That's part of the problem.
It turned out it was pretty quickly.
It was very quickly. They got out of there. Oh, dear. It sucked a few boats down. They popped back up again. That was big problem, that one.
Yeah, it's funny. You watch big trees getting sucked down into it. It was wild.
Yes. That was one of those, a comedy of errors when you look into what happened, why they were even drilling there in the first place. And then they drilled too far. They did know that the mines were there, but they drilled too far down and eventually wondered why the water level started to drop all of a sudden.
Whoops.
Yes. Ah, dear. Sad. Hey Terry, good to see your cars on the road. Well, not on the road, sort of making noise.
Yeah, it's very noisy, but it's running. Just need to drive it sometimes.
I'd forgotten that engine bays used to be that empty.
Yeah.
Because you look at a car now and there's barely enough room to move a spanner. But I mean, you could hold a party in there. Bloody hell.
That's right. Well, just so I think Bloom is probably the closest he needs to keep an eye out. There's a floater laser test apparently going on.
Oh.
That's today in my time, so.
Laser test, you say?
Great Salt Lake laser test. There you go. Meet at the Walmart.
Globe versus flat. Well, you've already lost.
So, yes, there you go. Collab. Beehive skeptics are going to do a laser test over the Utah Lake. Don't know if they're going to.
What are they going to lie about this time?
Well, beer and food is a bit of a worry for a start. The food maybe not, but let's do some proper stuff. So,
does Tim know that he's providing the beer and the food?
Yeah, well, I'm not. I can tell you that. So, this video doesn't do anything. It just plays a few pretty pictures and then puts that screen back up and.
They'll be shining a laser over a body of water and going, look, I can see the laser all the way over there. Therefore, Earth is flat.
Yeah,
or something. Because that's generally what they do, isn't it?
It's usually not a very.
That's the one that Dan the Waterman keeps relying on every single time, isn't he?
Oh,
yeah,
only because he was there.
And every time, then when he gets put under pressure about explaining it, it's not me. I didn't do it. I wasn't even there.
Right. Yes. Where's it? Where's the results? Where's the measurements? Oh yeah, no, you have to have that.
Yeah.
So,
but it wasn't me. I didn't do it.
But they have them.
I don't have them.
Have you seen them? No, I haven't seen them.
They keep saying they've got them. They've got them. I haven't got them.
Yeah.
Why do you keep bringing it up, Eddie? You haven't got the fucking measurements. Stop bringing it up. Twat.
And they're not bringing it up. So bringing up the measurements, are they? Yeah. Anyway, it's something to anyone that in that area wants to go, and that would be fun to just turn up and see what they had, wouldn't it? Do you think you could pretend to be a flat earther?
Just sort of point and laugh.
Well, the trick is if you wanted to sort of infiltrate, do you think you could just, as soon as you said anything intelligent, they'd know you weren't a flat earther, right?
Yeah, cover blown. Yeah.
Right.
So, have you collimated that laser then? Oh.
Whoop, sorry. Yep. What are we using to check who we've measured? Oh, well, we'll just get someone to tell us if they see a light. That's it. Okay.
Yeah.
That's it.
That's all they did before. Can you see the light? Yes. Well, there you go. Then Earth is flat.
That's flat. Yeah. I found something on TikTok. So Blue is part of a secret cult. By the way, did you know that?
Oh, is he?
Yes.
Oh,
Blue,
that's nice.
Can I join?
No secret. I don't even know about it.
Yeah.
Yeah, well, you obviously haven't had the memo yet. You're in it, but nobody bothered to tell you.
Yes.
Well, it's his cult, apparently. He has to get the memo that it's his cult.
I gotta make sure I got the right one. This was a TikTok one.
When a pilot signs at the end of flight school, there's this little portion that basically says what happens in flight school stays in flight school, and if you were to talk about some of the things in the manual, well, it's a matter of national security. I don't know. It's so strange.
Really?
But if this were true, no pilot would be able to talk about it. But the flight manual itself was actually pretty easy to find, and it admits a flat, non-rotating Earth.
This is insane. Watch. Seashore.
No, it doesn't.
Go to a seashore
Yeah, you want to see this bit now, I think.
and figure out why you can't, if you live on the East Coast, figure out why you can't see Spain from the East Coast of North America.
So Bill Nye is saying if the Earth is flat, if someone's standing here and then standing here, they would be able to see it, right? Even if it's hundreds of miles apart. But no, that is blatantly wrong. He's basically lying. And I can prove that by this picture. Everything that you see in the distance goes down to a horizon. For example, this hallway, it's the same distance from the floor to the ceiling all the way down, but look how it gets smaller at the end because it's farther away. That's exactly what would happen on this map. But he's saying the reason you can't see from so far away is because the earth is bending over and you can't see on that other side of the bend. Everything goes to horizon. Is he blatantly lying or does he just not know?
No, you're
And seeing as they're
sick.
Yeah, they're not Genesis, so that's not good. Yes, so you signed your life away, Blue, apparently, if you went to flight school. So you cannot talk
there
about
you go. That's what it is.
Hmm.
That cult, all right.
Must have missed that part too.
Yes, I think you did.
So is that what they said in flight school when you first started to learn Blue? You can't talk about it. Is that what they said?
No, they didn't say that at all. Come to think of it.
Oh, okay.
I was going to say, I'd like to know which bit of flight school they introduced that in.
Yeah.
It's at the end of it.
The RAF, no, was it in the RAF, Alan? Did they say that in the RAF?
Well, obviously, I only did glider training, so there's when you're learning to fly a glider, you don't really worry about navigation. In fact, you don't worry about flying more than circuits really till you've gone solo.
Oh,
See,
you're not part of the cult then.
No, well, it is because he's been flying a glider. He has to stay even more silent than the other pilots.
Yeah.
Yeah, because there's no engine sound to cover up the conversation, is there?
Yeah.
True.
Yes. So anyway, that's what it is. It's what it is. I do have. So it must be about time to send you all off for a Lindsay bingo card. Don't you think it's about that time?
Yeah, I was going to say we played bingo today.
Yeah, we got bingo today. We haven't had Lindsay for 2 weeks. Come on.
It's been lovely.
So I'll just get some cards out there. Hang on. There you go.
I won't bother because I'm expecting a phone call shortly, so I'm probably be quiet. So I'll
any excuse, any
excuse. I'll sit and listen, but
there we go. Get some
I like
cards.
this new, easy on the eyes blue background.
You like that one?
Yeah.
Yeah, I thought I'd do something a little bit
On the
different.
Lindsay bingo card. I like the new easy on the eye blue background.
Yes, it's a. I thought
The black
change it
hole
up a
is
little.
black.
I'll change it up a little bit. Make the black hole appropriate. Give people a bit. So, get a few together. I better get Lindsay up and running. Hang on a sec. I do have.
Why is it flipping
Bloody
cold
cold out
today?
there today, isn't it? It's
Yeah. And it's raining.
Yes, it's raining. It's 7 degrees at the moment, and yet on Wednesday it's going to be 18. I don't know what the fuck's going on with our weather.
Yeah, well, last time I was sitting out in the field, wasn't I? I was almost outstanding in my field. Well,
almost.
Just like Jan True. Don't want to be doing that today. It's not very nice out there.
So were you standing or were you sitting?
I was actually out sitting in Fred's field rather than my field.
Yeah,
but
outstanding.
Yeah.
Subtitles on. So
Cool.
Cool. Makes it a bit easier. Okay. So today's one is North and South Poles is a global lie.
Okay.
Just so you
How do
know.
compasses work?
Don't apparently.
Okay.
Well, I don't know. We'll just wait and see. Because okay, are we ready? Let's go.
I'm sure
Welcome,
Lindsay's going to
everybody.
clear everything up.
He will.
Welcome to my site. I call it the Tomb of Illumination, which is basically what it
that
is.
bit's
It's
coming along, isn't it?
illuminated.
It's getting
Gonna.
more and more.
Purpose in life is to become
Yeah.
illuminated as well, because we are all of the earth fractions.
Sorry, I shouldn't say this, but the fact maybe they weren't letting near sharp sharp implements might have something to do with it. I don't know.
Of the overall system. Or we can think of it as an eye, an eyeball. And what do eyeballs do? They see the light. We have to open up our third eye to see the light. Come into the light, understanding creation and all that helps you ascend to a higher frequency to get out of the matrix. But if you want to stay as a globe believer, you'll stay stuck in the mud
Then to a high frequency.
at your
to
lower
get out of
self.
the Matrix.
Yep.
And never wake up.
Okay.
But those who do seek the truth have come to realise the earth is indeed flat. We have all the evidence. We can understand it. And so you've opened your mind, and you open your mind, you are seeking. So if you seek, you shall find. And this is part of conscious development, ascending, receive the higher frequencies. Otherwise, if you're not seeking, you just stay dumb. And which brings me back to the initial name of this video. It was going to be called the 10 dumbest questions globe believers ask flat earthers. Well, I only got as far as the one and realised, well, that's a video on itself. So number one here is, how does flat earth have two hemispheres? This is one of the main questions you get from these ignorant people who think they live on the outside of a spinning ball called a globe. Well, hemi means half, right? So we come to understand the flat earth system. If you're new here, this is what it looks like as a side, as a slice, as a, what do you call them? Not an elevation, it's a cross section. Okay? There's the plan view and the cross section. Now you might get confused because look how small the north is, right? This is if you could see Earth as one, if you're one of those imaginary astronauts, you could see the Earth, it would look like this. Small northern hemisphere expanding out to the south. Everything expands out from the centre north. Okay? So we're going to get into understanding this expansion in this video. But this is another way of drawing it, where we see the two northern hemispheres and the southern hemisphere.
Two northern
all around
hemispheres.
it, right? So centre north, you've got the central vortex of creation right in the centre here.
Did you say southern
Which is
hemisphere?
basically this here. A hole, just like a ring magnet.
No, you don't have to. I don't have
Like a
either
ring magnet. We're
hemisphere.
just going to talk a bit more about that. Just expanding on previous videos I've done. Because I come to realise something. I was always humming and hawing how the magnetic field flows, and I've come to understand it now, so I'll share it with you. So, you know, like there is another way of drawing this, like following this,
Promises,
where the
promises.
northern hemisphere shrinks away, but that gets confusing. You just got to open your mind and try and think, because understanding flat Earth takes a lot of thinking. It's not just a stupid design like they show you with the globe. Okay, it's way more complicated than that. And this is why the people run this world show us the globe, because they know you're dumb or think you're dumb. They want to treat you as though you're dumb. They want to keep you dumb.
Complicated.
The dumber they keep you, the less likely you're going to wake up and realise what's going on. So they do not want the truth out there. This is why us flat earthers are shadow banned, or you make no income off it. But I'm here anyway to share the truth. So let's get into it, eh? So hemi means half. So there's a half there, and there's a half there if you want to go that way, across the ring magnet. Imagine it's this very small hole in the centre here that we cannot get to. We try to get there, but we cannot. It's basically the black hole. You cannot go into a black hole from its side. You have to come in the door, which is basically the Milky Way. You've got to get into the Milky Way, the passageway, or causeway, to get in there. Okay?
Oh, we're not already in the Milky Way.
We cannot get into it.
No.
No. This is where the sun sits on its horizon. The sun does not get sucked into a black hole. No,
You have to go to the Milky Way to get into the black hole.
The hallway up in through the Milky Way. It's basically where the sun sits anyway, because there's one end of the Milky Way comes out, and the other one comes down. So you've got one end of the Milky Way coming up and over into it, and the other end just comes straight up into it, which is straight up off the Arctic basin there. sits like that. Let's bring back up here. And then you get the Milky Way comes from the tropics. The electromagnetic field, the end of it comes over into the top. Or straight magnetism comes up this way.
Straight
Once again, I'll be talking about that. Magnetism being attracted to the electromagnetic, and the electromagnetic being attracted to the magnet.
What?
So hemi is half. We have a northern hemisphere, so you go south and north, so there's two hemis. And what do you have inside your head? You have two hemispheres to your brain, don't you? Well, they're not spherical, are they? So that's how stupid these globies are. They understand the Earth's brain as having two hemispheres, but they can't understand the flat Earth having two hemispheres. Because flat Earth is not only about the dielectric plane between the two fields, the positive field and the negative field. It's about its flux, like a magnet. It wouldn't be a magnet if it didn't have a magnetic field, which creates the flux, magnetic flux, would it? No, Earth wouldn't exist either without the magnetic flux.
And then Orion's built.
It's basically the metaphysical magnet. It's a physical magnet, we understand that. Well, our physical world is not creation, is it? We are created from this magic place called creation. It's all hidden up in here, all hidden in that dead center. We've all been expanded. We're an exploded view of this dot, 0 point. Okay? So flat Earth isn't just about its flat plane of inertia. It has what we know in magnetism as flux, which is our...
Sorry, I just got distracted by a sec to read the back of his piece of paper.
So flat Earth isn't just...
Good morning, darling. I am going...
to run a load of washing in Algiers while I run back 1 hour.
Wait, he's doing his laundry
cooking
now.
bacon.
What?
Weird.
Well,
back in 1 hour, 7:20 a.m. We'll cook your bacon and eggs.
Oh. Good morning, darling.
With the nice love hearts.
Is that to his missus or from his missus, I wonder?
Or was that him writing it, or is it her writing it? Yeah, I don't know.
Yeah, exactly. Yeah.
That's not his handwriting.
No, it's not.
No, it's not, is it? Yeah.
Anyway, sorry. Distracted by that.
And at the bottom of that PS, you're fucking bonkers.
Sorry, anyway.
Good. Playing inertia.
Okay.
I see there's playing inertia on there, and I thought I had that. Can't find it.
No, we want state of inertia.
What state of inertia? Don't have plane of inertia, sorry.
Ah, okay.
Not plane, yeah.
I want Orion spelt, and I've got bingo. But anyway, I can't see that coming.
Like the Earth's atmosphere thins or weakens in pressure, the higher or further away from its plane, so too does the magnetic pull of a magnet weaken the further from the magnet. Okay? Earth is just like a ring magnet. It has a north and south pole, doesn't it? Yes, but we have been lied to in regards to where these opposite poles are or what they even mean. Allow me to explain. Well, that's what I'm going to do today in this video. So, we need to understand the magnetic field of the Earth, how it flows. We are told that we live on a ball. Let's draw another picture of a spinning ball, shall we? Just for laugh's sake. Show how stupid those people are who believe in such garbage. And then we'll just put an equator line there. And of course we have to put an imaginary stick there, don't we? Just so we don't get confused about which way the spinning ball is top or bottom. So we have to draw a stick like that. It's for brain manipulation. And then you put a bit of a spin on it, okay? So they tell us there's a North Pole and there's a South Pole. And they want you to believe that the magnetic field goes all the way around to there and goes in that way. All the way around there and goes in that way. 100% rubbish.
Bigger than that, but...
Total garbage. In our flat Earth system, the field comes up out of the centre north and it comes up out of the south. They both rise.
Well, if it didn't,
There's
you
no,
wouldn't be alive
There's
right
no
now.
exit and entry, or entry from the south over to the north. Exit from the south over into the north.
What?
Because the
No,
magnetic field of
just-
Earth does not cross the tropics. The tropical gap. That's the neutral zone. That's the place of avoidance. Just like the black hole. Okay?
Must be
Everything
spiritual
avoids the black hole. It
awakening,
spins around it. Okay? But down here, it's a changing magnetic field because it's
Spiritual
avoiding
awakening. There you go,
this
you
gap,
You said it.
this
Alan.
tropical
You
gap.
said it.
The magnetic field does not flow like the rest of the
Say
Earth.
bingo, Alan. Go on.
There is no magnetic field in the tropics as such. What happens
Serious?
is the magnetic field flows up out
Yes,
of
I
the north,
know. It definitely is.
goes to the tropics and drops straight down. Then shoots along this way, rises up, and shoots down this way.
All right.
Why does it do that? Well, in physics they understand there's a strong force and a weak force.
How does it do that
And it's
then?
basically what the North and the South Pole is, the way they've described it with their ball. Okay? But in reality, with this flat Earth system,
Goes
this is
along
the
it,
weak
just
force.
changes direction for no
Weak
apparent
force.
reason.
Well, what does it do?
all
Can't
the way
point
around
anywhere.
south. Okay? And you've got the strong force in here,
I
very
don't
strong.
know.
Okay? So, the field rises up out of the north to seek its opposite. And where's your opposite? Well, the opposite's here. Right there. That's not a south.
Is it?
That's a
Why?
north pole as well. That's north. And so is this. It's north. Okay? And these are their souths. The
You
field
North Pole.
rises
Oh,
from
right,
the
okay.
north, and the field rises from there. They are both the same pole, you could say, but they're only different in regards to strength. There's a strong force. Strong force is in the centre. Strong force.
Please say meridian.
And out here we have the weak force. Of course it's weaker. It's way more dispersed.
Meridian. There you go. You said it.
As it comes out from the strong point, it weakens. Just like our earthly field, atmosphere weakens as you further you get away from the flat plane of inertia. Everything expands south. So the strong force is always seeking the weak force, right? But it can't cross the tropics. Because it's a neutral zone. It's a place of avoidance.
Neutral. Okay.
Okay? I know this drawing's sometimes confusing to people who look at that. They're not quite understanding it. You've just got to go with me. If you can see the whole thing as one, because man does not see as he expands, it's all relative to the observer as he moves south. He does not see expansion or contraction. Everything is relative to the observer and he sees it in equal form. So let's just say we're seeing all this in equal form. We're not seeing the expansion and contraction. If we did, everybody on Earth would know 100%. There'd be plenty of proof there, wouldn't there? But they don't see it. That's the trick, that's the magic of creation. Okay? Just like I've done in the previous videos. There's a 2D plane of creation. That's the ecliptic plane. But it creates a magnetic field depth. So these circular motions in here become an S-curve motion in this depth. This magical zone is where we all come from. That's what creates Earth. Projects out, there is there, and creates our realm. Bit deep, but go and check out my earlier videos. Or you might have to get on my Patreon, actually. Most of my stuff is on Patreon. If you really want to learn, you need to get over there and pay a few bucks. If you really want to know the truth, that's the real deep esoteric knowledge, you're going to have to pay quite a bit for the saints. Get into the saints. Pay that one-off fee, get the base video, and you start to understand everything. Everything about flat Earth, everything about all the esoteric knowledge that's been left for us by the Egyptians. It's right through all religions. You need to get that base video to understand everything. You'll be rapt, you'll be pleased, and you'll be blown away with the information that's in there and what's coming. Okay, so back to the flat Earth. You've got a strong force always seeking out the weak force. And the weak force...
Sorry,
Somebody said
Dr.
bingo. Oh, good.
Dr.
I mean,
Dr. Nimrod said bingo. Oh yeah, post your link, Dr. Nimrod. Let's check it out. We'll see if it's real. We can check your card then, you see.
Are you saying?
I
Are you
have
saying
got
he's
so
lying?
many things crossed off.
He's clearly
Here we go.
telling the truth. It's fine. Don't worry about it. It's okay.
No. You need to post the one that you were ticking all your things off on.
Yeah.
So you see, I can tell. You see, you go into here, you post that link. I reckon that. Yeah, nah. I'll have to keep playing it till I get that link. Sorry about that. I just need him to say. I just need him to say Orion's belt, and I get bingo.
I need Meridian.
Spiritual Awakening would do.
Did he say Vortex yet?
Yes.
Yes.
He has said Vortex.
All I need is sun or umbilical cord.
Oh no, he said sun. Definitely said sun. He said that at the beginning.
Did he say
He
sun?
said sun.
Yeah.
Oh, well then I've got bingo.
Oh, there you go.
That'll do.
That's good enough. Okay, you jumped in my Discord. Yeah, you could, or you could just paste your link and I'll take it, but I will let you share the screen. Hang on. Oop, not that button. That button. There you go. Let me switch so people can see. And Dr. Nimrod says he did do it. I'm just checking. Looks like we've got 2 bingos.
There you go. Right across the top there.
Ah.
I nearly had a diagonal as well. All I needed was umbilical cord. Is that verified?
Verified. Good enough for me.
There you go.
Works for me.
Except for Matt's going to complain. Matt wants to keep going. Dr. Matt.
Really? Do I? All right.
Well, yes.
Given half the chance, I would have cheated somehow. I would have figured something out.
So, yeah, somebody
if you would have said state of inertia instead of fucking plane of inertia.
Yeah, no. Well, I was waiting for plane of what was the other plane? Esoteric, whatever it was. Yeah, there's another plane that usually goes on about. That wasn't there either.
Do you think?
Yes, Dr. Nimrod, I do believe you.
And what he does, he changes the phrases every now and again. He watches the show and changes it just to keep us on our toes a little bit.
Should do. Yeah.
I just want to verify. In my Discord. Send a Discord, DM? Didn't come through. At least I can't see it, but I do believe you. A minute. I believe Dr. Nimrod got it first, then Paul just verified it. So we'll go that way. Sounds good to me.
Yeah. Doesn't matter who got it first. The fact that somebody fucking got it.
Yeah, exactly.
Yeah, who cares?
I was so bloody close. I mean, my 2 cards, my other card, they're just all over the place. But the first one, I had a lovely diagonal. All I needed was Meridian, but I don't think he was going to get there with that.
Am I right in saying then, according to his theory, that we've got 2 North Poles? In order for me to get to one North Pole to the other North Pole, I have to go through the black hole. Would that be accurate according to his
something like that? Yeah, I think
weird model, something like
that. I like the way he says that the magnetic field zooms all over the place. It goes across here and then shoots down here and then travels across up here and does a U-turn and goes back down here. And
yeah.
Oh my god.
For no apparent reason, just does. Reason.
It even goes back over its own path in the opposite direction somehow.
Well, I like how all the different magnetics are affected by the other magnetics. So,
yeah,
electromagnetics is drawn to the Earth's magnetic, which you know.
It's got me puzzled how a compass ever fucking works on his flat Earth.
Well, would be obvious that if you stand on the equator, the compass doesn't point anywhere; it just spins around or something.
It's got to point 2 directions at once, apparently.
Changing the subject slightly. Have you seen there's a thing going around in YouTube Shorts at the moment as well? There's this guy interviewing a flat earther, and there's an old guy, and apparently there's not just one sun. Everybody has their own sun. Everybody on Earth has their own individual sun. So there's literally billions of them. Yeah.
So you take on the personal dome, is it?
Yeah. He probably thinks he's got your own personal dome as well.
What the bloody hell's mine then?
Yeah.
That's mine.
When's my son going to eclipse your son?
Yeah. And it's and it's no more than 50 minutes at any given time. Oh, and it's not hot. That's the other thing he said as well. So your sun is not hot. Although he made a mistake. He said originally the sun. He said, hang on a minute. No, your sun is not hot. 50 miles.
How come my son looks like your son?
I know, weird that.
Yeah.
Yes, and seems to go in the same places also.
Come on.
Now Matt's not claiming your son Matt's not claiming your son anymore.
Yeah. He can pay child support.
I've already got one. I don't need another.
Yeah.
I've got one pain in the arse. I don't need more pain in the arse.
Okay. I found this video.
You're a pain in the arse, aren't you, Ben?
I found this video. Took my what they actually do found in the New York sewers.
Oh.
So I'm gonna play. Hang on a second. Play. There we go.
Oh, it's a frog.
Yeah, no, it's not a frog.
An alligator. It's an alligator. Yeah.
It's an alligator.
Little gator. Yeah.
So there are gators. So there are gators in the New York sewers. There you go. Proof.
Yeah.
Wow.
Only little ones though, because that's not a very big pipe is in. But anyway.
I'm sure some conspiracy nut would say that there's dinosaurs living in the sewage system or something.
Well, yeah.
Or lizard people, or lizard aliens or something.
What else did I find on video? I did find some more flat
I
earthers.
thought the lizard aliens all lived in Kensington Palace.
Well, that as well.
And Buck House.
Yeah.
No, they don't live there, do they? None of them live in Buck House.
Well, in residence then. They're not there all the time, but they are some of the time.
Well, that's kind of like that's kind of like a live-in accommodation office for Buckingham Palace, isn't it? Really, sort of.
Yeah, I thought they work. I think they work there and occasionally stay over, but not. I thought as much as possible they sort of didn't stay at Buck House, especially at the minute while they're doing it all up.
They're not still doing it up, are they? They've been doing that for bloody years.
Yeah.
Oh, yeah. Apparently King
Charles.
Charles.
A lot of it, isn't there?
Apparently King Charles.
Yeah,
King Charles
granted, it's a fair size.
Apparently King Charles, our king, tries to avoid staying at Buckingham Palace as much as possible. Apparently, from what I've been told.
As did the Queen.
As did the Queen. Yeah.
Yeah.
Yes.
Yeah, the Queen much preferred, well, out near you, Alan, didn't she? Well, ish near you.
Balmoral. That's where they.
No, Sandringham.
Sandringham or
both.
Or Windsor.
Or Windsor.
Yeah. I found this just to have an interlude between flat earthers.
Oh, he looks familiar.
Hey guys, Backyard Scientist here, and behind me is the world's most powerful vortex cannon. It shoots a vortex ring out at over 350 miles an hour, and it's aimed directly at my head. Well, a little bit above it, because honestly I'm kind of scared of this thing, and you're about to find out why. Fire! Now the crazy thing is you can't see the vortex because it's shooting rings of air, which is, well, invisible. But you can definitely hear it. That noise is the invisible vortex ring just ripping through the air. It sounds like an invisible fighter jet flying through a field. This thing shoots a concentrated tornado, and before I shoot myself with this thing, I want to do some tests. So for the first test, we're gonna shoot these cardboard boxes. Fire! Whoa! Oh my gosh! Look at how powerful that is. It just shreds the boxes, rips them apart. When's the last time you were able to shred a box just by slapping it? The aim was a little high that time, so we're gonna lower the cannon and try again. This is when the vortex hits it. This.
What's that, sorry, man?
The Germans were testing this concept towards the end of the Second World War.
Yes, they were.
Yes. So. I'll try again.
Fire, fire, fire! Whoa! My gosh! It demolished it. It went right through. Oh yeah, nailed it, nailed it. Now if you slow this down, there's a couple cool things that happen. Number one, you can see the shockwave from the blast hit the boxes before the vortex ring does. It doesn't look like much, but there's a cool editing trick. Take a copy of the clip, stack it on top, and then move that over by a few frames. Then take the difference between the two clips. This highlights and amplifies motion. Now you can see the shockwave much more clearly, and you can even see the vortex ring moving through air, and that's because it slightly bends the air like a lens. Now I told you this is like a tornado. I mean, look at how far it threw those boxes. It picked them up and threw them about 40 feet, and I don't know about you, but I tried my hardest, and I could only throw a box like 25 feet, so this is pretty cool. That was so awesome. Dude, it shredded those boxes like a piece of tissue.
It's a very expensive toy so far.
Yeah.
Yeah.
They get it to.
Where did he get it from? Must have hired it or something, did he? Or, I don't know.
Yeah, I don't think he made it.
That's one way to trim a tree. Now the tree is only 500 feet away and it takes the vortex 2 seconds to reach it. If you miss the tree though, the vortex keeps going and going and going. According to this clip, the vortex traveled over 2,000 feet. That was so cool! The key to making a good vortex string is a short, fast burst of air. This cannon uses rubber bands and the giant cannon uses explosions. So right here we have the name of the cannon, the VRAD. They have outfitted this thing with a 28-inch barrel on this end, and on this end is where you fill up the gases. So right there they've got some liquid oxygen, which they mix with a bunch of different gases in just the right ratio to get the perfect explosive mixture, which shoots the vortex ring out of the end right here. Now you can basically think of this like a giant single-shot rocket engine because, well, it is. There's a combustion chamber, converging diverging nozzle, and fuel and oxygen injectors. So I always thought that the vortex ring was formed inside the nozzle, but it's actually not. So when the gas comes out of here, what it does is it pulls the air from the outside into the stream like that. So you get a short, fast burst of air, and the air from the outside comes like poof, and whips into the stream and makes a vortex like that. Now,
what do you do with something like that? Apart from YouTube videos. I suppose you could make some money going to shows and stuff and displaying it or something or other, I suppose.
Yeah, I suppose.
Oh, military breakthrough. We can destroy incoming missiles at a distance of 50 feet.
Well,
yeah, I'd much rather rely on other missiles and failing that, the R2-D2.
We could blow over one individual who got within 20 feet of it. I suppose in theory you could use it for drones, but yes. I do know there is some vortex cannons being developed for taking out aerial drones, like for small drones, not big drones. Yeah. Yes, of course there'll be a tank. Apparently, I don't actually think you mentioned a tank. Did you mention a tank, farmers?
No, were mentioned at all.
Not in the last 5 minutes, anyway.
Nope. Well, not so far today.
So there you go.
Will it take down an unladen European swallow?
Well, if it sits, definitely will if it sits in the middle of the tunnel. Yes.
Make a damn mess out of a Cessna.
If it's close enough, yeah. Yeah. Might knock them out of the sky as they're coming in for a landing or something. Anyway, that was a bit of a distraction.
Quite a dangerous thing, really.
Yeah, it could do.
You don't want to get too close behind a heavy jet.
No. That's right.
Wingtip vortices are very violent.
Yes. What else have we got for us? Well, you all know about Flat Earth Day, of course. You know what day that is. Don't you? Don't you know what day Flat Earth Day is? What? Really? Surely.
.99% of Earth's population. Are you one of the people who think that 99% of Earth's population can all experience daylight at the same time?
Yes.
This comes up every July now. I'm not even sure when this started. It hasn't been too long. Last July, last summer, I shot a video on this because I have a globe and I tried to prove this and I wasn't able to do it. I lost that video on my other account and it came up in question this week on another video, so I'm going to reshoot this video. So here we have a globe and here we have a sun. What we're going to do is point the sun at the globe and we're going to see what we can come up with. So the first topic that the globe proponents will say is, you don't know how big that Pacific Ocean is. The Pacific Ocean takes up half of the globe, which it doesn't take up half the globe, but it takes up half the globe, and that's what makes this 99% of daylight possible. So we're going to bring this big ocean back here to the back. We're going to put the Terminator line right here on California, okay? Because we want the United States. A lot of people live here, and we're looking for people, not land. So we're going to cut this off in California. Let's come over here and see what we got. So what we've ended up with is over half the population of China is in complete darkness. This has to be in daylight. Indonesia, way back here is Australia. It's all in complete darkness. Look at all this land that's in complete darkness. There's too many people here.
The Terminator line on the edge of
so
China.
Let's bring that Chinese population back on the Terminator line.
Yeah.
Let's step back over here and see what we got. Well, looky there. Over half of the United States is now in complete darkness. To get 99% of the population, you've got to get more than that. Look how much is.
That's only 300 million people.
Yeah, that's right.
South America.
Well, look, all
a lot of people.
Well, most of South America, yeah.
Down here, you can't get 99% of the population in daylight on a globe. It does not work. So if you'd like to join us in the comments down below, give me your opinion on what I can do differently to make this work, because I've tried this. I've tried it with the act.
He hasn't added those populations together to see if it, what the population is, has he? So he just thinks that America has half the world's population in it.
Of tilt pointed in a different direction, and that actually makes it even worse. So you have to point it like this, which is the way it's supposed to be for that time of year. But I can't find any place on this globe to where 99% of the population experiences some form of daylight all at the same time. It does not work.
July 8th is known as an impossible day on the globe. It's due to the fact that the globe gets to be illuminated in almost 70% of its surface. This cannot happen because we all know that according to the ball Earth, the sun illuminates half of the ball Earth. Flat Earth is proved on this day.
I wanted to say this comment concerning.
So there you go. That's when, what day that was? July 8th is Flat Earth Day, so remember that.
I'm going to say, isn't that 70% of the land surface of the Earth is illuminated?
Yes.
Yeah.
And if you take that image, this guy's got the Terminator line just clips the edge of America through to this edge of Asia. So, assuming that's accurate, that seems to make sense. So, okay. Anyway, there we go. Put that in your calendars. Be ready for it. Speaking of that, what else have I got on my list? Mr. Curse with a high IQ, do you have a quiz for us today?
I do.
We do.
I actually do have a quiz. Yeah.
Oh, great. But how about I do an Everett, and then maybe we might do a quiz.
Right.
I haven't done Everett. I've got a few to do. So where's my Everett squad? There they are. Yes, I do want to do that. Okay.
we live on a flat Earth. We do not live on a globe spinning around in space. That is the biggest lies of lies, and this is Satan's last years, and he's deceiving the nations.
I'm the devil, and I'm here to say I'm the most evil rapper in the USA. All my homies and my bitches say,
And you're in the nation of deceives. Well, I'm trying to get out the nation of deceives. I'm in America, so it's gonna be a little tough. You know what I'm saying?
Are you sure his brain is okay?
Absolutely. Watch this. Charlie, identify these objects, okay?
Ba. B. Ba. Bilba.
He's fine. Great job, Charlie.
Thank you.
We should not be having a debate because the globe is the truth, apparently, right? It's proven. We're in space and we proved it, right? So if that is the truth, why, when we see birds going over the horizon, it looks like it's going down? Why not the planes?
Will you stop? It's just a piece of fruit. Eating a piece of fruit is not going to change your life.
Yeah, but what if it's magic fruit? What if this fruit makes me the smartest man the village has ever known?
That's a pretty low bar.
So you tell me your reason and explanation for this one, Globers, because you won't. Because this is not even a debate.
Now you've done it.
Well, I definitely feel something. Less hungry for one, but also more intelligenter.
You just make it look like the globe is the truth. Everything is CGI, everything is fake and lies. Or really the flat earth is the real debate. It's not even a debate, it's just truth.
Ask me something, anything. Go. Test me. Go.
All right, where does the sun go at night?
Pass. Next question.
We live on the Earth, right? It's pretty funny when I think about this. That's spinning with water on it in space. I'm about to disprove it right now, but if you think that we live on it, then you're about to get disproven until you prove me right.
Yeah. That's not gonna happen.
Because these stars match exactly with the Great Pyramids of Egypt. Each one of them match exactly with it, right?
You know what you need?
What?
I have Ativan. You want that?
Oh, yeah.
Little Valium?
Oh, yeah.
You like a Clonopin?
I want something to take me sky high.
How? How does that make sense if we're spinning around through space? Spinning. It doesn't matter. It doesn't matter. You just shouldn't be seeing the same stars either way. And even Polaris. Polaris, the big star. Hopefully you know what Polaris is.
Huh?
Polaris.
We have these to hold down the sound, sir.
Polaris.
Oh, good. Thanks.
Bro, wake up. Wake up. No ball. Yes, flat.
He's experiencing denial.
What's that mean, Dr. Crane?
Well, simply put, it means that the human mind blocks out that which it cannot emotionally accept.
What's that mean, Dr. Crane?
It means that you don't understand this, and you never will.
The sun and the moon are the exact same size. You might be thinking, what are you talking about? Science tells us that the sun is way bigger, and it's 400 times bigger than the moon. But the thing is, I don't believe in this. So I don't believe in science. I don't believe in NASA, which means to deceive the Hebrew. I don't believe in none of this stuff. I believe in the truth.
Okay, one last time. These are small, but the ones out there are far away.
Far away.
They are both equal. That's why you see the moon is equal. But sometimes the moon looks higher.
So wonderfully, 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 wonderfully pretty.
It looks smaller because it's higher. It's higher in the sky. That's why it looks a little different. But no, really. Example, solar eclipse. How do you think it's the same size? Same size.
Small, far away.
Far away.
Ah, forget it.
He doesn't get it. Okay. Need some brain juice. You ready for this? On a scale of 1 to 10, how hard is your quiz, Paul?
I don't know, about 5.
About 5.
So it's 11 then.
I don't know. It depends on if he asks us questions that we know the answer to.
Well, yes. Because if you know the answers, then it's really, hello.
Easy.
Easy, yeah, that was the word I was looking
Yeah, does that look very hard?
I don't think some of the
dinner.
Yeah, dinner. Yeah, lunch. For some.
I've always found that I like to keep abreast of the situation.
All right. Shall we proceed?
Yes, let's do.
No.
Yeah.
No. All right. A university in North Carolina study by David Williamson, performed 15 years after this event, found that its negative effects lingered far longer than was expected.
Farts.
What event? Any ideas?
Trinity.
No? No, not Trinity. Good guess, but no, not Trinity. No. In one of his last bombings, Ted Kaczynski targeted young and Rubicam executive Thomas Mosser for his role in manipulating people's attitudes about this event.
Oh, God.
No.
No?
No,
Okay.
not me.
Investigative journalist Gregory Palast claimed that this event was caused by the shortcomings of the RAYCAS radar system, the RAYCAS radar system.
I can't think what the event would be.
Well,
I promise you will get it in the next few clues.
It's got something to do. Okay, go.
7 fish processing companies based in Seattle filed a lawsuit in the aftermath of this event and were awarded a secret settlement totaling around $70 million.
Would that be Fukushima?
Not Fukushima. No.
Long Island?
No, not Long Island.
Well, I just looked up the guy. He's the Unabomber.
Yeah, that's who Ted. Yeah, I know who Ted. What's his
Ted
was?
Kaczynski, yeah. Yeah, they've done quite a good series on them a little while back, but I can't think what the
event was.
It wasn't what the Unabomber did. It was what the people
said that people did.
He
Yeah.
targeted.
Yeah.
Night Island.
Exxon Valdez.
Night Island was heavily damaged by this event, which was caused by a vessel carrying cargo from Prudhoe Bay. The Exxon Valdez was it. Well done, Alan. Yes.
Yeah, the front fell off.
Yeah. Joseph Hazelwood was reportedly drunk when this ship struck Bligh Reef in Prince William Sound. You would have got it from that, surely. Triggering this event, which was only surpassed in volume by 2010's Deepwater Horizon disaster. Yeah. Named this 1989 environmental disaster caused by an oil tanker running aground off Alaska. It was the Exxon Valdez,
Yeah, I remember that being all over the news.
Some oil.
Yes.
Leaked a little bit of oil. The front fell off.
Yeah, just some.
Yes, that's before they found.
Roughly translated, fucking shitloads.
Yeah.
Well, a shipload.
A shipload.
Yeah, a shipload. Yeah, which is shitloads.
Yeah. All right, question 2. Form factor F2 of the vertex function equals a contributor to this quantity.
I thought you were talking about a pharmaceutical or a cosmetic there for a second with that form factor. But okay.
No.
F2, that's what leads you into F1.
The E821 experiment attempted to measure a value of this type, which deviates from standard model predictions by 3.4 standard deviations. Not a toroidal field, no. The fact that deuterons have a smaller value for this quantity than protons reveals that it is negative for a neutron. What is negative for a neutron?
A neutron having a very bad day.
Hey. Not the muon mass, no. Confinement through mirroring is possible because this quantity is an adiabatic invariant. In G-2 experiments, the anomalous portion of this quantity is measured, whose one loop correction is equal to the fine structure constant over 2 pi.
Well, they're all words.
Come on, what did the G-2 experiment measure?
I don't know. I'm trying to work out what's negative for a neutron because I thought they didn't have negative or positive. Okay.
The ratio of this quantity to a particle's angular momentum is the gyromagnetic ratio. Ooh. Winner, winner, chicken dinner. Turing test 2 has got it.
Got it?
Oh.
Was it the muon or the
Turing
magnet?
test 2.
Yeah.
Or the magnetic moment is indeed the correct answer. Yeah. A constant defined as fundamental charge times h bar over 2 times the electron mass is used as the unit for this property for an electron and is named for Bohr. Yeah. Name this quantity equal to the current of a loop times its area, which indicates how much torque an object will experience in a magnetic field. It is the magnetic moment.
Okay, there you go.
Well done, Turing test.
Picked up.
2.
Nice. Would Turing test 1 could have got it?
Huh?
Would have Turing test the first? Would they have got it?
Well, then he would have been Turing test 2. Okay. Question 3. Okay, you'll get this one easily. A cast of one of these objects is pierced with nails in Clifford Rainey's sculpture, The Martyrdom of Saint Sebastian.
Oh.
There's a particular clue in this set that I know you'll all get this one from. Not an arrow, no. A ceramic face has one of these objects inserted into its mouth in a sculpture by the mononymic artist Marisol. The Calipagean curves of these objects were given to them by Raymond Loewy, the man largely responsible for their modern design.
Oh, is it a bow? Like a long bow? No.
Nope, not a long bow, nope.
Okay.
3 of these objects figure into a Robert Rauschenberg combine that includes a pair of bird wings. Not a tree.
Can't vision any of these.
102 of these objects figure into a painting made with the silkscreen techniques of Andy Warhol.
I think Turing test has got it again. No, Turing did that one.
No, it's not a cross.
Not a cross?
Not a cross, no.
Not a cross.
You'll get it after this clue. Z travels to the end of the world and throws one of these objects off a cliff at the end of the film. The gods must be crazy.
Coke bottle.
Yeah, see, I told you you'd get it. Yes, that's the one. A Coke bottle. Yeah.
Bloody film's that?
I haven't seen that film.
No, I haven't seen that one.
Haven't
you? Haven't you? And it's so fun. It's so popular. Made the gods must be crazy too.
Yeah. The giant one can be found at an Atlanta exhibit showing the world of the company that uses them. Name these glass objects which hold a beverage produced by a soda company. It is the Coca-Cola bottle.
No, the storyline of The Gods Must Be Crazy is this, a guy flying a plane throws one out the window. It lands in this tribe in Africa that's never seen one before. And they originally find it really useful for, hammering things and rolling, and then they start to fight over it. And then the people say, why would the gods give us something so divisive? And they send this guy off to throw it off the end of the world. So it's his funny, crazy mayhems as he tries to find the end of the world.
All right, question 4. An artist from this movement who painted herself with her bare back turned to the viewer in Le Passage was profiled in Whitney Chadwick's influential study analysing its female artists. What movement? A hyena acts as a sort of recurring familiar in several paintings by an artist from this movement, including in a self-portrait in which she sits on a tiny blue chair in front of a white rocking horse.
What's that called? That movement?
That's what I'm asking. What is it called?
Yeah, I know.
After being institutionalized in Spain, that artist from this movement took advantage of a marriage of convenience to a diplomat to move in Mexico City.
You're not talking about the surrealist movement.
I am talking about surrealism.
I was going into one that's much more obscure than that. And then when you gave that one, I thought,
would that
you're
be
not
Picasso, the guy?
You're not.
Yeah. At this movement's first MoMA exhibition, a female artist exhibited a cup, saucer, and a spoon, all covered in fur.
Yeah. MoMA.
You would have got it from that, surely.
Yeah.
An artist from this movement depicted his wife as a seated Madonna in a painting set on the coast of Port Liget. 2 female artists from this movement, Leonora Carrington and Merit Oppenheim, had affairs with a more prominent member who pioneered rubbing and scraping techniques called frottage and grattage. Gala Dali was married to a leader of what art movement? Surrealism.
Yeah. That's why you're avoiding using Dali's name earlier in
I like
clip.
Yeah.
I like some of his, but a lot of surrealism is well, shit.
Surreal.
Yeah.
Not just shit.
I think it depends how you look at things.
Yeah.
I think the trouble is a lot of people don't realise when most of the movement was, and they only see pictures a lot later, and so you have a bit of understanding of history. It makes some more sense. But not a lot of sense.
What about music? All right. Interpreters of this composer's music include Reinbert de Leeuw, as well as the pianist of the album After the Rain, Pascal Roger.
I don't think I know enough about that.
Nope. Okay. He called for instruments such as a lottery wheel, a typewriter, and a pistol in a ballet that includes The Little American Girl and a ragtime of the steamboat. He was a bit weird, this guy.
Yeah,
sounds it.
Oh, we've got a winning already. Turing Test 2 is on fire today.
I don't know who that is. So.
It is Eric Satie. Yeah. A piano piece by this composer begins with the left hand playing a low G and then a long B minor triad in the piano's middle range. This composer of Je t'ai vu and Parade wrote a collection of piano pieces with tempo markings such as slow and painfully, slow and sad, and slow and serious. He was renowned for putting weird things on his music. Yeah. Though his relations with them later soured, this composer was the main driving force behind the formulation of Le Six. Yeah. He is known for a collection of 3 very slow, ambient piano pieces whose name comes from an ancient Greek dance. Do you know what pieces those are?
Nah, no? I don't know this guy at all.
Named as composer of the Genopodes, it is Eric Satie.
I will point out that in following up who he was, my Google tells me that people who looked up him also were looking up Ozzy Osbourne. So,
okay.
All right. Okay.
I don't think there's any relation between them.
I don't know, but that's what it says.
Oh.
Yeah,
I know one of now I just looked up, think, hang on a minute, I know one of those bits of music. Was that
yeah.
what it was?
Yeah.
Well, I don't know. That guy looks a bit stoned as well as Ozzy Osbourne as well. So I don't know. Maybe.
Yeah. they're quite well-known bits of music. Those Genopodes and Gnossians.
Yeah.
But if you look into his history, he was really a very weird fellow.
So it's Ozzy Osbourne.
Yeah, exactly. All right. Question 6. If a polynomial equation Q has a root for this operation applied to the equation Q with respect to a prime P, then there will exist a unique root for Q for this operation applied to a power of P by Hensel's lifting lemma.
Okay, what are we looking for?
That's quite Wales.
Okay.
I'm trying to ask what the question is yet.
Yeah. And odd prime P is expressible as the sum of 2 squares if and only if a form of this operation applied to P yields one according to one of many results called Fermat's theorem.
Okay.
We have a winner out there already.
All right, there we go.
Nerd Alert has got the correct answer with modulo. Well done. He knows his maths. Yeah.
I prefer Dora's
The
answer.
2 numbers A and P are raised to P minus 1 divided by 2 applied to this operation of P gives the Legendre symbol, giving conditions for when the golden theorem can be satisfied. Yeah. Both linear and quadratic residue classes are defined using this operation. Wilson's theorem states that a number in n is prime if and only if n minus 1 factorial is congruent to -1 of this function of n. A percent sign is used to represent what operation that gives the remainder after division.
Percentage.
Nerd Alert got it right. No, it's the modulo operation. Yeah. Well done.
I prefer Dora's answer, Optimus Prime.
Optimus Prime. No. Yeah. All right, question 7. A 2013 book subtitled A Voyage That Changed the Atlantic World chronicles the journey of a ship of death which spread this disease to multiple ports of call. What disease?
Would that be bubonic plague?
Not bubonic plague, no. During one epidemic of this disease, the pseudonym Anthony Benezet was used in multiple letters urging people to employ black nurses in the mistaken belief that blacks were immune to it. No. Charles Leclerc was felled by this disease, which killed off a majority of the French expedition to retake Haiti from Toussaint Louverture.
I don't know about that, but if it's not, is it yellow fever? Oh, sorry, Turing's already got it. He's already got it.
Yeah, he got it. He got it before you. It was yellow fever.
Yeah,
Yes,
yellow
well
fever.
done.
Yeah.
Yep, yellow fever. No. Yeah. Building on the work of Cuban doctor Carlos Finlay, Army doctor Walter Reed proved that this disease was not caused by drinking polluted water and used his findings to decrease the transmission of this disease among workers on the Panama Canal. Benjamin Rush was a leading figure in fighting an epidemic of this disease, which ravaged the then capital of the United States. Named this mosquito-borne illness responsible for the 1793 Philadelphia epidemic. It is yellow fever. Yeah. All right, question 8. Bit of geography. This body of water is home to Baleine Island, which housed a concentration camp in the 20th century for political dissidents.
I've heard of Baleine Island.
A popular tourist destination is viewing this river's namesake bend from the Julianus Lookout from the town of Vac, or Vach.
So obviously it's Northern Hemisphere, Iceland, somewhere along those lines.
Lake Titicaca. No. Its namesake flat is home to the Great Rye Island, partly because the rye crop is cultivated there.
I found the answer, actually, only because I Googled it.
But Turing Test got it too.
Again, yeah.
Again, he's on. He's doing well today.
Danube, yeah.
The Danube,
yeah.
Danube is correct, yeah. This river, which is classified as the 7th corridor, is home to the Huken, a type of salmon native to this river. A country built a namesake canal to connect this river to their Tisa River. The Razim-Sino Lagoon complex can be found south of this river's delta, which is home to the ports of Salina and Tolcha. The Breg River serves as the source of this river in Germany, which flows for 1,777 miles before emptying into the Black Sea in Romania and the Ukraine. Named the second largest river in Europe, it is the Danube. And I was amazed looking at this. This graphic shows the expansion of the Danube Delta over a period of a couple of thousand years, and how much it's actually deposited and changed the landscape. Yeah, quite substantially. Yeah. Okay. Question 9. You'll get this one easy. In 1973, this group held a council at Kampala and established a set of principles that it would follow, such as justice, creativity, and honesty.
73.
This organisation consolidated the philosophy of Ernst Seton in establishing a law program for various braves, maidens, and princesses. That program featured Indian guides.
Oh, that's so funny.
Not the Flat Earth Society, no. It most recently updated its principles by adopting the Challenge 21 initiative in 1997. Almost 140 years earlier, this organisation adopted the Paris Basis of 1855 as a group of principles to uphold. Not the Girl Scouts, no. This organisation was founded by the London clothmaker George Williams, who sought to promote muscular Christianity during the Industrial Revolution. Matt?
I think it's the YMCA, but
it is the YMCA. Well done, Matt. You got it. Yeah. James Naismith invented the game of basketball while at Springfield, Massachusetts training school, run by what Christian organisation known for its association with recreational sports? That should have given it away. And if that didn't, this would have given it away.
Yeah, the picture certainly would have done.
Yeah. The YMCA. Yeah. All right. Last question. The critical properties found at this point are notated with superscript asterisks, and their ratios with their corresponding stagnation values equal, misspelt that, the 2 over quantity 1 plus the heat capacity ratio, all raised to some power. At an aperture near this point, when downstream pressure drops below a critical value, the flow rate becomes independent of downstream pressure, or choked, as can be seen in the convergent-divergent nozzle designed by Gustave de Laval. Not the triple point, no. Flows near this point are typically simplified by being treated as isentropic. The Rankine-Huguenot conditions model a phenomenon that occurs above this point.
No, keep going.
Density fluctuations begin to be considered significant at around 30% of this value, above which flows are treated as compressible.
Speed of sound?
The speed of sound is it. Well done, Alan. Yes, that's correct. This point can be defined as the square root of bulk modulus over density. Above this point, shock waves begin to form. That should have almost given it away. Name this value found in the denominator of the Mach number, equal to about 340 meters per second for air. It is the speed of sound. Yeah.
Very good.
And that was your quiz for today.
Thank you very much.
Thanks for that.
Well done,
Appreciate
Turing
it.
test too. I think you got quite a few of those.
Pretty well, yeah. Got a few in there. So Kenny answers. Yeah, go on.
No, that's all right. Go on. Go ahead. It's all right. What do you
Oh no, it's all right. I was just doing a segue. You can speak. It's all right.
No, I was just going to say I stayed at a YMCA hostel, I should say, in Brecon Beacons. We were doing like a part of the Duke of Edinburgh. We're doing like a hike around the Penny Fan. You got the famous fan dance, the SAS do around that area. The weather got really, really horrible, really bad, and we were kind of quite a long way from where we needed to be to stay at this campsite and things like that. So we couldn't stay out in the weather. So we found this hostel, and you could either pay a certain amount. I think it's like 20 quid a night, or if you chip in and like help cook and wash up and all that kind of stuff, you could get it for like something about a £5 a night or something. So yeah, the weather was really bad for a couple of days, so we just stayed there until it was all over and we carried on. But yeah, really good place. Treated us really well. Anyway, that was just my thing.
Dora, South Wales, not Scotland.
What's that? Sorry. Oh, sorry.
South Wales, not Scotland, because Penny Van's in the Brecon Beacons, isn't it?
Yeah, that's what I said. Yeah, South Wales.
Yeah.
Did I say Scotland?
No, Dora.
I don't know. No, Dora said bad weather in Scotland. Unthinkable.
Oh right. Okay. No, South Wales. That's right.
Yeah, I've done Penny Van as well. It's not a pleasant walk in February when the snow's coming up the cliff at 120 miles an hour.
Yeah, it was horrendous. Yeah, if we'd stayed out at it for too much longer, we probably would have come down with hypothermia and all kinds of stuff. But yeah, it got really horrible really quickly.
When they send rescue teams out.
Yeah, we didn't go all the way to the summit because we figured that getting the same that happened to a couple of SAS guys the 2 weeks before we went was a bad idea.
Yeah, well, we didn't.
We
either,
like
but we
liked
on the way
being
down,
alive.
Yeah, no, we didn't go to the summit of it. We kind of contoured around it, but we were kind of on our way towards that direction when the weather started getting really bad. And it was just like we were absolutely drenched. I mean, like everything was wet. Literally everything was wet. And I think if we tried to camp out, then yeah, it would have been pretty bad, I think. So yeah, if it wasn't for that YMCA place there, we would have been in a lot of trouble, I think.
Yeah. I got to spend a week there early February, thanks to the RAF.
It's not the right time to go in there.
Under canvas.
No.
Hey, it was week 5. It was week 5 of the course. It was always week 5 of the course. I started my course on the 2nd of January.
Yeah. Still not the right time of year to be going there. Bugger that.
No, we were there in March, but it just got really horrible and really wet and cold, like really quickly. Visibility wasn't great.
That's
either.
the problem with Wales. You just never know what you're going to get.
Yeah. Well,
we got a long range forecast, and they said it was going to be scattered showers and maybe some wind and stuff like that. But we got far worse.
We got snow and 100-mile-an-hour winds on the Tuesday. On the Thursday, it was so warm we were walking in shorts and t-shirts.
Like that, isn't it? Yeah.
I'll go back to my segue. Okay. I'm trying to fit that in now. So I thought I would point out something else that was really silly. So I thought you might like some math lessons. So
where's Bob?
What the Haversine equation does is it finds that angle alpha that's directly over my head. That is the angle formed by drawing a ray from the center of the Earth to your starting location, and then drawing a second ray from the center of the Earth to your ending location. Those.
So let me break down what the Haversine equation is, and then I'll break down the Haversine formula.
Oh no, it's him.
But first off, Haversine means half sine, and this allows them two 90-degree angles. So
no, it doesn't, dipshit.
I was waiting for you to say something.
Down to a plane underneath a hemisphere. So they'll have two 90-degree angles. Now, the Haversine equation is basically just a claim. And what it claims is that the angle measured from the surface of the hemisphere, from the beginning point to the ending point, is equal to, remember, equation means equal to, so the angle measured from the surface of the hemisphere from beginning to end is equal to the same angle down on the center of a plane underneath the hemisphere. So really it's just a claim. The reason they do this is because these calculations do not work from the surface of the sphere. They have to go down to the center plane of the hemisphere.
It shows his understanding, doesn't it?
Two rays will form that angle alpha, and that's what the Haversine equation is designed to do. You then apply the Haversine formula to find one of two things, depending on what information you start with. You either find the distance along the surface of the sphere between those 2 points if you know the radius of the Earth, or if you know the distance between those 2 points because you drove it and measured it, you can use that to find the radius.
Yeah, but that would be assuming you're measuring a hemisphere in the first place. And find a significant distance, straight line driving distance in the first place. I'm just making claims. Haversine uses a radius. Or using the distances from a model that already has the radius.
Yeah. Now, in order to find angle theta, what we can do is use a little bit of trigonometry and something called the Haversine formula. Now, the way the Haversine formula works is that we divide this angle in half, right here.
So I wonder why he didn't draw the baselines. He just, I guess he's ignoring it. Well, I'll tell you what, Bob. I'll go ahead and draw them in for you. I'll draw in your two 90-degree angles so you can have your Haber-Sign formula.
What's he doing that for?
I don't know.
Now we want angle theta, which is this entire angle here. What we can do is we can solve, and that angle, we'll call that alpha. Angle alpha equals angle theta divided by 2.
So that's basically like saying 2 plus 1 minus 1 equals 2. It's stupid, but technically it's not even theta. Because theta, this is the definition, theta is either the azimuthal angle on the xy plane or the vertical angle, which is that angle measured from the z-axis out to the point in question. And he didn't measure from there. He came up with an equation, but technically that's not even a theta. He didn't measure from there.
Angle theta equals 2 alpha. So notice that there's absolutely no radius involved in any of this.
So why would he even claim that? I'll tell you why. Because we're going to tell him you need R for that. But what he's going to do instead is use given distances from longitude and latitude lines from said radius. So you need the radius one way or another.
What we're doing is we're employing the Haber-Sign formula to find the Haber-Sign, which we're calling angle alpha, in order to determine what angle theta between the starting point and the ending point in the center of the Earth. Now,
one of the problems that I run into with flat earthers is their inappropriate demands for particular tests or measurements. For example, they only accept physical measurements, i.e. with a tape ruler. They won't accept mathematical determinations.
Not at all true, Bob. We tried 1.22 times the square root of the observer's height in feet to measure your globe horizon, and it failed.
So I got to thinking the other day, what if I could measure the Earth with a tape measure? I wonder if that would be good enough for them. Well, let's find out. Ladies and gentlemen, here is a direct measurement. This is the Southern Cross Cable Network. It is a series of undersea cables between Australia, New Zealand, Fiji, Hawaii, and the western United States. The origin and destination of each of these cables is documented, as is the length of the cable. It goes from Alexandria, New South Wales, to, forgive me if I mispronounce this, but Winnipeg, New Zealand. So how do we determine how far it is on a flat Earth between Alexandria and Winnipeg? Now again, since this is a flat surface, we can use Euclidean geometry.
It's all Euclidean geometry, Bob. That's why you had to transfer your measurements down to the center of a plane projected up to the hemisphere above you, because you can't calculate from the surface of the hemisphere. It wouldn't work, Bob.
If we draw a line from Alexandria to the North Pole and calculate the number of degrees between Alexandria and the North Pole, we can calculate the length of this side of a triangle.
So what Bob wants to do is start flat Earth off at the North Pole. In reality, these latitude angles are measured from the equator, and when they do their angle measurements on the globe, it is observer dependent. So these angles should be measured from the observer, not the North Pole. Now Gleason's map is centered around the North Pole, but if you're going to use a latitude-longitude coordinate system, then you have to center yourself from the observer, not from somewhere you're not, but from somewhere that you are. And I don't think Bob understands this. But we'll let Bob go ahead and do his math and just
I think he does.
His straw man out to the end, and then we'll go to the AE map.
But why would you use degrees for latitude on a flat Earth?
And we'll compare him to Bob's straw man.
Yeah.
And see if his calculations match flat Earth calculations. Something tells me that they won't.
Now, the coordinates for Alexandria are 33.9 south, 151.2 east. So to get the distance, it will be 90 to the equator plus 33.9 times 111 kilometers. That distance will be 13,752.9 kilometers. Likewise, we can do the same for Winnipeg. The difference in longitude between Alexandria and Winnipeg is 23.4 degrees, so that's this angle at the North Pole. Now on a spherical Earth, we use something called the Haber-Sign formula. Now if you thought that the law of cosines was a mouthful, let's look at the Haber-Sign formula. The Haversine of the distance between those 2 points is the sine squared times the change in latitude over 2, plus the cosine of lat 1 times the cosine of lat 2.
So there's your proof that he is doing these calculations from a plane and projecting the calculations up onto a hemisphere, because he's using the sine of latitude 1 times the sine of latitude 2. Well, the latitudes are all calculated from the celestial equator, which is a plane.
Times the sine of the change of longitude over 2. Now, once you have the Haversine, we actually need to do a little more to it. To get the distance between the 2 points, you take 2 times the radius of the Earth times the arcsine of the square of the Haversine, because the Haversine is a sine squared. So on a flat Earth, that's how long the cable has to be to go between these 2 locations. Now, on a spherical Earth, the great circle distance should be 2,141 kilometers. We've already calculated the flat Earth distance as 5,651.9 kilometers.
So according to Bob, that city right next to Sydney, out to the coast of New Zealand, on a flat Earth has to be 5,600 and something kilometers. So let's check the online AE map generator. So we center his coordinates right by the town next to Sydney, and we put a total radius of 3,000. So from the center to the edge is 3,000 miles, and we went clear past New Zealand. So how could it be 5,600 kilometers when 3,000 kilometers goes clear past New Zealand in full? So Bob doesn't understand the way the AE map works, or else he wouldn't be strong.
I think he just misunderstood it.
But let's bring it down to 2,000 kilometers from the center, and there you see New Zealand just barely poking in the 2,000 kilometers. So there's your distance on the AE map on a flat plane. It's more like 2,000 kilometers, or just a little bit more than 2,000 kilometers, because from the center to the edge is 2,000 kilometers, Bob.
That's not on a flat plane.
It's the actual length of the cable. Based on published records, the cable length between those 2 locations is 2,276 kilometers. Okay, what's this tell us?
It tells us you full of shyster, Bob.
Well, first of all, the minimum distance it could be on a spherical Earth is 2141. If it's anything greater than that, that doesn't rule out a spherical Earth in any way, shape, or form. However, on a flat Earth, the minimum distance has to be 5651.9 kilometers.
Sorry, Bob, but I just used the AE map generator.
Yeah, which is based on a spherical Earth.
Flat Earth distance is closer to 2,000, maybe 2,100 kilometers. Pretty close to the distance you came up with all that unnecessary math. But thank you for watching. Please like and subscribe. See you in the next one.
There you go.
I'm about to plug in this fan to test whether
We'd expect that if you put the origin at the origin of your cable, that the AE projection would give you the correct length for the cable.
Yes. Well, the projection map from the globe will give you the correct length. Yeah.
Yeah,
that's right.
And it's when you center the AE map at the North Pole and do it that you get the wrong answer.
Yes. So he's suggesting that the Earth changes depending on where you're looking at it from. So, yeah, I don't think he understands that the AE generator is not of a flat plane. They're generating it from a curve. Silly man. Silly man.
Sorry, I was back. I was away.
You're back.
Did I miss anything?
Not a lot. Misunderstanding math as they're prone to do. Yeah. I wasn't going to play the whole of this, but do you guys know that Professor Dave's done another video?
Oh, I'm seeing
Hey, everyone.
He's done 200 proofs, hasn't he?
Yeah, I watched it.
I have much. It's an hour and 20 minutes. So
Yeah.
Because Debay has put out another one, so I like the start of this. I was just going to play the start of it. So.
It's been quite some time since I've talked about flat earthers, even if they never stop talking about me. But although this...
Which is one thing I like, because he was the last time I put out a flat earth video.
Yeah.
They still bring him up.
Self-proclaimed champions of flat earth change over time, most of their brainwashed flock still seem to bring up one particular guy as their messiah, and that's Eric Dubay. If you're not familiar with this buffoon, he's a pointless grifter and yoga teacher who took a garbage 19th century book by Sam Robotham called Zetetic Astronomy, Earth Not a Globe, and shamelessly repackaged it for today's gullible masses with some crappy pamphlets and YouTube videos collectively entitled 200 Proofs Earth is Not a Spinning Ball. Despite having been debunked countless times, flat earthers somehow still reference this tool, so I thought it would be fun to go through all 200 of his so-called proofs and show how profoundly stupid they really are. Wouldn't that be?
Well, a lot of them are.
He does point that out, yeah.
Yeah. A lot of them are just repeats. Yes.
Yeah, I think it's less than 2 dozen, isn't it? I think, or around 2 dozen.
When you boil it down, yeah. Yeah, it's not many.
No, that's right. Oh, I thought I had a Wally. Where's Wally?
There was a chap going back several years now. There's a YouTube channel called Rhetoric and Discourse.
Yeah.
And his logo was a cat. And he did it in chunks, but he very painfully went through all 200.
Yeah.
And it was 3 or 4 years ago now, I think. But yeah, he did point out that, this one's that one and that one and that. And he Dubay just keeps repeating himself again and again and again. Because I guess otherwise he'd have said, look, we've got this huge number of proofs. 7, 10.
I don't
200 sounds
understand.
better.
I don't understand why he's got such a big following, because he's not doing anything different from anybody else, apart from doing like a big video and producing a book. I mean, what's special about him?
I think he was pretty much the first one to do what he did. And it just and a lot of flat earthers when they've been asked and said, when did you start thinking the earth was flat, it tends to coincide with when Dubay first put that out.
Greater Sapiens doing a series of debunks on him too. He's slowly working through each one, going through them in quite a bit of detail. But I like Professor Dave's attitude towards it much better. Like, saying, what a buffoon, what an idiot, like he doesn't really take him seriously at all, which is what he deserves.
Yeah.
How can you take these people serious?
Oh, look, Gary Widebothers in the chat.
Yes, I saw that.
Right.
Not with anything new.
Twat.
Nah, so while I was looking for Wally, because I can't find him, I'll put on some Dave, a different Dave. Oops.
Hey, hope you're doing well, and thanks for joining us for another video. One of the most fundamental observations for centuries regarding the shape of the Earth has been objects disappearing from view bottom up.
Very
in exactly the same way as we see other things go out of view bottom first over curved surfaces.
Oh, yeah.
Flat Earthers, though, of course, need to provide alternate explanations for bottom-up obstruction. In recent videos, I've tackled claims that it's changing atmospheric conditions. Those are too inconsistent and not always matching what we should see if those were the case. And I've also tackled claims that it's perspective, allowing small objects nearby to obscure distant objects due to angular size differences, which is flat earthers getting perspective completely wrong. And today I'll be tackling a demonstration I've seen multiple flat earthers put forward of apparent proof that bottom-up obstruction would naturally occur across a flat surface. The demonstration in question involves placing a camera at the end of a table and then moving an object along the table away from the camera, and it disappears bottom first. But then when they zoom the camera in, the object comes back into view, which then leads towards the claim that we can zoom objects back into view after they've gone beyond the horizon. However, it may come as a surprise to very few people that that is not actually the case. So today we'll cover why there are flaws in their demonstration, the crazy effects of optics that can make it appear as though they are zooming objects back into view, and I'll even throw in a bonus debunk of everyone's favourite demonstrable realist who has recently fallen foul to the exact same misconceptions seen in some ISS footage. Because at the end of the day, I can see how those demonstrations could lead people to believe that objects would disappear from view bottom first over a flat surface. And we're all human, so, everyone gets stuff wrong from time to time. I don't think there should be any shame in getting things wrong. I see it as an opportunity to learn from it and learn something new, which is one of the reasons I love using Brilliant.org, who are sponsoring this video. Brilliant makes learning easy and enjoyable with its use of simple and interactive animations for classes across maths, science and computation is the obvious question. Are we certain that the camera is correctly aligned with the table? Is it looking just across the surface as should be the case for a flat earth representation, or is the camera actually slightly below the table? Well, the demonstration that was done by Mitchell from Australia tries to address this issue by lifting the camera up and then lowering it back down.
Nice flat table, no physical obstruction. This is all optical.
Yeah, he moves it below.
Except when he lowers the camera back down, it looks
goes below the table
suspiciously
again.
as though the camera is slightly below level. Level would be when the near end of the table is perfectly in line with the far end, just as though the table were being extended out into the camera. However, in his footage, it does seem as though the camera continues down slightly further than that point. Although it's difficult to tell from the footage because it's not perfectly clear where the ends of the table really are, partly due to the low quality of the image, and partly due to the highly reflective tabletop, which is reflecting the wall in the background, making it really difficult to tell where the far end of the table actually is. However, the reflections of the chairs on the table do give us a clearer indication of where the side edge of the table is. And I would argue at this point, the camera is actually level with the table, but it then proceeds to drop slightly further than this. So it looks like Mitchell from Australia's footage is below the table. It's hard to tell from Flat Out Truth's video though, because he doesn't raise the camera up to show us. Now, Game Changer's setup is definitely below the table, but I'll get on to how we know that in a moment. Firstly though, I need to make sure that everyone is familiar with depth of field, because that's going to be very important to this. Depth of field refers to the areas of the image in front or behind of the subject that you're focusing on. Basically the areas which are out of focus. So if you see a portrait, for example, with the background very blurred, this is referred to as having a shallow depth of field. Whereas images like landscape photos, where everything is clear from very close to far away, is said to have a deep depth of field. I find it easier to think of it as depth of focus, and it's affected by three factors: focal length, aperture ratio, and subject distance. Although the focal length and aperture ratio are kind of linked. If you were to take lines from either side of the lens's iris opening and have them cross each other on the subject, that is the point where the lens is focusing on and thus is perfectly in focus. As those lines get further apart, things get more out of focus. If you physically open the iris up, then the lines are starting further apart from each other and thus will move away from each other quicker, so things will drop out of focus faster than if we had the aperture closed down. When we zoom in, we're actually magnifying the appearance of the iris across the front of the lens, and so again the lines will be starting further apart, and so things will fall out of focus sooner, whereas zooming out to a shorter focal length creates a deeper depth of field. And last but not least is distance. With the camera right up to the edge of the table, the difference in distances between the camera to either end of the table is huge. So if we focus on the closest end of the table, the far end of it goes out of focus. If we focus on the far end, then the near end goes out of focus. Now, I recreated the setup along this countertop behind me, but I did it in a more controlled manner. The camera I used was my Sony a7 IV with a Tamron 28-75mm lens, because on this lens there's a little white marker which is used as a guide to align where the lens mounts to the camera, But when the lens is locked in place, it sits exactly in the middle of the lens mount, meaning it's running across the middle of the sensor. So I placed a spirit level onto the camera to ensure that the camera was sitting level. And when I lifted the camera so that the marker on the lens was meeting the bottom of the level, I knew the surface of the counter is sitting exactly halfway up the camera lens. And when I place an object in front of the camera and then move it back, the bottom does not go out of view. Now, Game Changer used a very similar setup. They also had a spirit level sticking off the edge of the table, except you can clearly see the underside of their spirit level, and the underside of the spirit level is rising up in the frame as you get closer to the camera, meaning the camera is below the underside of the spirit level and thus below the top of the table. I can only reproduce the flat earther's results of disappearing bottom first when I lower the camera down slightly, which obviously isn't possible on a flat earth unless you're standing in a ditch. Another clue that this demonstration from flat earthers is flawed is that their objects begin disappearing as soon as they move them away from the camera, which is not what we see in reality. In reality, they appear to rise up first and then start becoming obstructed whilst dropping down, which we can produce perfectly on a table, as long as the table has a curved top to it. However, you might be thinking, hold on, if the camera is lower than the top of the table, then why did zooming in bring the object back into view? Shouldn't it just have zoomed into the edge of the table? And this is where things get pretty cool in my opinion. When I first saw this demonstration being done, one thing I immediately noticed is that when the object in question is getting moved back, the camera focus does not move with it. If the camera focus was set to follow the object, then as it moves back, the camera would shift to track it, or at least track the person's hand. This would cause the near edge of the table to move out of focus, but it doesn't. The camera's focus is staying fixed on the edge of the table, and the object is moving out of focus. Now, all camera optics have what is called a minimum focus distance, which is pretty self-explanatory. It's the shortest distance away from the sensor that a lens is able to render an object in focus. Now, the distance varies between lenses depending on their optical design, but the general rule of thumb is that lenses with longer focal lengths have further minimum focus distances than shorter focal lengths, unless you go down the route of specialized lenses called macro lenses, which are designed to allow closer than normal focusing and are what is generally used for close-up detail shots of objects. However, in any zoom lens, at least that I can think of, the shortest focusing distance is always on the widest end of the lens, and it increases as you increase the focal length. For example, my 28 to 75mm lens, at 28mm, it can focus down to about 18 centimeters. But at 75mm, it can only focus to 38 centimeters.
What's your favourite lens, Ella?
My favourite lens is the Sigma 150 to 600 Contemporary, and that has a fixed 2.8 meter minimum focusing distance at all focal lengths.
Oh, there you go. Not sitting on the edge of the table.
But it's at least not reversed from the usual. You wouldn't get it reversed, But mine's I'm stuck with 2.8 meters regardless of the focal length.
So as I zoom in, the minimum focus distance is actually increasing whether I like it or not. And that is what is basically happening here with the table in the flat earthers example. The camera's autofocus has locked onto the table edge, which is why it doesn't shift when the object gets moved back. But once they zoom in, the minimum focus distance is getting pushed back, so the edge of the table is going out of focus, and the focus is moving towards the object at the far end. I can actually reproduce this same effect of bringing objects back into view without even zooming in. As we covered earlier, zooming in creates a shallower depth of field because it's magnifying the apparent size of the iris opening. So not only when they zoom in is the minimum focus distance being pushed back towards the object, but the iris is being magnified so that it can appear more over the top of the counter. In the footage at the moment, the camera is set to f22, which is the smallest iris opening this lens will allow, and the bottom of the object is clearly obscured by the countertop. However, without zooming in, if I just open the iris up from f22 up to f2.8, the iris is now much bigger, and part of it can see over the top of the counter, and the bottom of the object now comes into view. As long as part of the lens has line of sight to the object, the obstructions can be blurred out of view. Photographers use this regularly to their advantage. Common examples are having things like tree branches or fairy lights just in front of the lens, and then focusing on something way off in the distance so that that obstruction in the lens becomes massively out of focus and leaves just blurry remains, which photographers do just to add some character to the photo. I mean, one of my favourite photographs that I have ever taken was this of a tiger crouched down by a shallow pond. I shot this with a 200mm lens, and I was standing less than 10 metres from the tiger. Now, I would like to make it clear, I am not suicidal. This was actually taken at Chester Zoo, and there was a chain link fence between me and the tiger, but because I had the camera so close to the fence and the tiger was set back from it, despite the fence going right across the front of the lens, it's being pushed so far out of focus that you just can't see it anymore, but you can clearly see everything that is beyond it. And this actually links us perfectly to the bonus debunk of Level Earth Observer, who recently put out a video claiming that footage taken on the ISS by Russian cosmonauts is apparently clearly CGI.
Oh yeah,
and that's what I want you guys just to have a closer look at, should we say. That silver seal, it looks like it's got little rivets in it. SpaceX Dragon capsule and that satellite dish up here are about to go through the windowsill of the Russian section of the International Space Station. Ridiculous. That's ridiculous, lads.
Now, you may have noticed the camera's focus jumps to and from the window frame. When it's focused on the window frame has hard edges to it, but when the focus shifts to outside, the window frame goes out of focus, which is when the antenna becomes visible through it. Now, here is the original video which Elio has taken the footage from. I'll link it below, but at 2 minutes 33 seconds, we can see the antennas are visible through the blurred window edges. But as they start to zoom the lens out, which increases the depth of field, the window frame is now brought more into focus and the antennas become obscured, which is exactly what we would expect to see from camera optics, as I've already demonstrated. I wonder if the demonstrable realist will accept this demonstrable fact that can be tested and verified by all. Well, that's going to be a wrap. If you've enjoyed this and you haven't already done so, then please consider hitting the like and subscribe buttons, and then hopefully we'll see you in the next video.
Nice.
Same reason Gary's Rayleigh criterion claim is silly. Anyway.
Oh, he hasn't got a fucking clue.
If what he was saying was true, why are they visible clearly and then suddenly decide to get smaller? It doesn't fit.
Yeah.
A bit more proportional to distance. Anyway, you won't pick that one up. So I think I was going to call it a night. I didn't find Wally. There's a Wally there somewhere. You guys want to?
That's something to do with this final experiment, isn't it?
Yeah, I think so. Well, yeah. I think you guys can follow it. Yeah, Leo's got published this final experiment thing, so yeah.
I don't think anybody's actually revealed, exactly what it is yet, but it's just something to do with Antarctica.
Yeah, they're going to go there?
Well, no flat earthers going to go there, are they? Must be joking.
Well, not.
Hang on. It's not a great big circle around the flat earth. There's no ice wall. Oh, shit. No, we're not going to go there. No. Because if that was all it needed, then several of the more prominent flat earthers who have grifted enough money would have already gone there and gone, look, see, it's flat. We told you.
Yeah.
There's a reason they don't go there.
I've been hearing you can actually charter an aircraft to fly over Antarctica, actually reasonably cheaply as well. Nothing particularly expensive.
I don't know about charter. There are regular flights.
No. You can charter them. You can charter them, and it doesn't cost a bomb.
Oh, okay. Because I think there is one mob that flies you over the edge, and sometimes slightly into inland. I have a feeling that's like 5,000 a seat, something like that. Can't remember. It was. And then there's around.
There's an aviation YouTuber, 74 Gear, who is a 747 cargo pilot, offered to facilitate that if the Flurfs wanted to pay.
Yeah, it's $1 million.
Yes, I remember that. Yeah.
Yeah, but it was $1 million, so that wasn't going to happen. He was trying to suggest that you could do it, like they could get enough people together to pay for the flight, and he'd organise the pilots. But his only thing was that he needed to be able to do it on his YouTube channel. But of course, it's not going to happen.
There's one particular company called Swoop Antarctica, Flights to Antarctica. You can literally charter a flight over 90% of Antarctic visitors travel by ship, which involves 4 days at sea and takes them a minimum of 10 days. Alternatively, there's a small but growing selection of flights to Antarctica to get you there within a few hours. So there you go. So they don't have to take out that much of their time, but plus, you could do reasonably cheaper, probably cheaper than actually going by boat. Ship.
Yeah, so you can do a flight over Antarctica for about $11.99. So that'll give you the economy. First class is the $8,000. But you get apparently what they do is they shift the seats around. So if you're in not in a window seat on one way around, then when they get halfway through, they switch it around so everyone gets a chance in a window seat.
Yeah.
So you can look out.
Well,
and
according
see
to this website, it says there's no scheduled flights to Antarctica. The only flights available to tourists are charter flights, which are only available as part of a package rather than a seat-only basis.
Well, this one,
flight.
This one's going from 24th of November. This is the next flight.
Okay.
So then these have been going for a while, and this is not the only company that does it.
So that is Oh right, okay. It's kind of like a mass charter, then I suppose.
Yeah. Well, they take. I think they're flying 727. I can't remember what they're flying. Something like that. That's the fly over it, and if you got a lot more money, you can actually fly to the South Pole. Not just to Antarctica, but you can fly to the South Pole, and that is not cheap. I think it's like 50 grand. But you actually get to go.
Oh that actually lands in the South Pole, though, doesn't it?
60. This particular one's 62 grand. That'll take you to the South Pole.
That takes them there in land, and they do a whole thing about it and all the rest. Blah blah blah. Yeah.
I know there's other ones where you can go to glacier camps and things like that. They're much more if you've got to be fit and willing to climb mountains and stuff for some of those. This one will be good. Sunrise South Pole. Go and see that if you ever win lotto and want something to do.
The sheer fact is that none of these clowns are going to go anywhere near Antarctica because
of course they're not.
They know what it does to them.
It's going to disprove them too easily, isn't it? Yeah. So yeah.
There's no 24-hour sun. Well, you can go and see it for your bloody self. No. But you can go there and look for yourself. No.
It is cheaper to go to the North Pole. Yeah, go on.
Yeah.
But
speaking about denial, changes the subject slightly. Whitsitt said in that InfoWars debate that you said that of course gravity exists.
Yes.
Well, apparently, people are saying on Twitter that he's been on Discord and he's denying it.
The gravity.
You didn't really get any details as to how he's denying it.
He's been explaining what he actually meant when he said gravity exists, and it's not as we understand gravity; it's how he understands it.
Oh, but gravity
What
exists.
you mean? The fact that there is a roughly 9.8 meter per second downwards acceleration.
Yes, that's what he's saying. Yes, of course there is. We know there is, but it's his explanation for it. So when he said, "Oh, of course gravity exists, little g," yes, he's saying little g exists, but not as we describe it.
Yeah, he didn't want to say it on that show that gravity didn't exist.
He's got an excuse for everything.
So what is it then? If it's not an acceleration, then what is it?
I can't remember. I saw it somewhere, but I didn't save it. It's a load of bollocks anyway, because he tends to go down the electric universe and electromagnetics road, doesn't he?
Well, so basically he's denying that gravity exists now, because he has to be. It's either it exists or it doesn't. There's no in between. It is what it is, or it isn't. You know, you can go both ways. Idiot.
Well, he's got an alternative theory.
He does. Not a good one, though.
At least he cannot. But at least he cannot now deny from now on in that gravity exists. So it might be a different thing he thinks.
Of course he can.
But he can't deny it.
Yeah, you just didn't understand him, or you've taken it out of context, or
oh, it's not what I meant to.
47B, you know.
Yeah.
Yeah, right. He was put into a corner, and he had to say it basically, and he's backing out. He's twisting it around.
Well, he did actually, and this has been pointed out at the very start of that debate. He did actually say that there is no evidence for the flat Earth.
Well, that's we all know that.
Apparently so. I mean, I haven't watched it, but apparently he did right at the start. He said there isn't any evidence.
I've already seen snippets.
He never gives any evidence for the flat Earth, does he? Ever?
No.
No.
He attacks the globe.
And he does that on purpose.
Well, that's why they all do.
I've heard him say it before. He's been selling conversations. That's why he basically tries to still man the globe Earth instead, because he can't produce any evidence for the flat Earth, and he knows he can't, so he doesn't.
Well, I mean, that's the thing. I mean, back in 2016, 17, you know, when it all sort of restarted the flat Earth again, it's kind of like they weren't doing that. They were coming up with all these different theories to support flat Earth. And now, all of a sudden, now they're all saying, oh, I'm not saying the Earth is flat. We don't know what it is. It's not a globe.
But because everything they've come out with has been debunked so many times.
Exactly.
Yeah. Now they have to go down the ignorance road, don't they? Oh, we don't know. Yeah. We don't know what the sun is. We don't know what the moon is. Well, we do. You might not, but then you're ignorant.
But it's easy though, isn't it? It's just a cop out, isn't it? Because then you don't have to defend anything. You know, it's easy.
Of course it is.
Just to say, it's easy just to sit there and say you're wrong.
Yeah.
Yeah,
some law or something, the amount of energy needed to disprove the crap that they come out with.
You mean the sun's a projection that we can bounce radar signals off?
Yeah. Don't know where it's projected from, but it's a projection, and it's small and local, and everything else that they all come out with, because of course none of them.
We don't know how far away it is, or what it's made of.
Well, we do. It's 3,000 miles, except when that doesn't work mathematically.
But,
yeah, anything.
But doesn't radar actually work? I thought we could rely on radar to know how far away physical objects were. Because
otherwise, that far away. Come on.
Otherwise, flying in an airliner would be pretty dang dangerous.
Yeah, but it only works on things that they want it to work on, and not on things that they don't want it to work on, like how far away is the sun?
Oh, you mean it's got to? You mean they say it will work for so far, but not for other distances?
Yeah, of course.
Well, they just cherry pick. They just cherry pick what they want and forget the rest. That doesn't apply. That must be wrong, because it doesn't agree with their bizarre theory, their belief. I mean, they're just a bunch of lying morons. That's all it comes down to.
Well, yeah.
All the time.
Yep.
Well, I've got one more, where is he? Not that one. I don't want to put a Leo on. Not this time, not. I got another Everett.
Good man.
Another Everett. I mean, what? Yeah, come to an end. I did have this changing on by flat Earth tests, but it was just basically that same, let's misrepresent this, and then we'll stick a refractive thing in it till we get the result we want, even though I can't show that happens all the time, and apparently only works on the sun and doesn't work on any other object that you can see. Yeah.
Selective atmospheric lensing.
Exactly.
So if you believe in the heliocentric model, you're a glober, then I'm going to need you to stick around. We have the sun over here and the earth over here. Something you need to know. The sun moving through the universe travels at such a speed that we travel from the sun to the earth, that distance, every 7 days.
Have you ever experienced loss of consciousness, hallucinations, dizzy spells, convulsive disorders, fainting, or periods of loss of memory?
Well, hasn't everyone?
But no. Mental illness or narcotic addiction?
Now, that's a tough choice.
So we travel the distance to the sun 52 times a year.
What the fuck does that even mean? Uncle Tamir, this thing is an idiot.
While exploding out of the universe, while our North Stars are on a 25,000 year rotation, while we're spinning at 1,000 miles an hour. Does anybody see the issue with this model?
How do I break this to you? You're a moron! Remember, go easy on him. Let me handle this. Can't, man. You're a moron!
So, I know everybody loves pictures, so I got some. Now on this side, we are starting with the launch site at the North Pole, and our target is the equator. But because of the Coriolis effect that you guys all tell me exists.
Okay, moving on.
We are not going to hit the target. The target will either be 15 degrees off because of the speed of the Earth, or we're not spinning.
Oh wait, I think he's moving.
If we are spinning at 1,000 miles an hour, and we have already agreed that the Coriolis effect is objects going up, the Earth is spinning, and the objects moving independently of the Earth. How do these land, take off, and fly against the spin of the Earth?
Have you spoken to the experts about this? Have you consulted Professor Bobai? Who? Professor Bobai, the one with the incredibly strong forearms that are missized for his body.
The man you are discussing is called Popeye.
Bobai.
He is not a professor. Popeye is, as the song tells us, a sailor man.
So I'll say it one more time. If we are spinning at 1,000 miles an hour, and this guy goes like 570, if we're spinning this way, and he's flying that way, he's gonna go real fast.
They're trying to sneak by a 2-cent beer tax. 2 cents! And what really gets to me is that the money they're gonna raise is gonna go for education. Well, I'll be damned if I'm paying 2 cents for some moron to learn how to read.
But if we're spinning this way, and he's going this way, but we're moving at 500, and the Earth is going at 1,000, he's going to be moving backwards, correct? Like that's how that would work with the Coriolis effect.
I am now 100% sure that you are watching cartoons.
Indulge me. For 1 second, pretend that I'm an idiot.
Okay, I'm there.
Now, I know me, common sense, math, basic stuff. So, is the Coriolis fake and made up, or are we not moving? Someone give me the answer.
But the fact of the matter is, you're a little bit... You're kind of a... You're an ass.
Doesn't want to hear the reason, doesn't want to hear the truth.
There we go.
You're going to get an astrophysicist explanation of the literal three-body problem.
No, you're not. Much as you might like to, you're not. Well, I'm going to call it a night.
Yep, fair enough.
Just like to say goodbye to the peanuts and set up for next time.
Good night, peanuts.
Okay, good.
Thank you for your attendance.
Thanks for coming. We'll see you again next time.